Okay, so what I'm going to do is I'm opening this site up, stackify.com/streams guide Java 8. I'm opening this up and I'm going to put it on the side here so that we can look at it. So please open that link up as well so that you can check it out. It's in the chat under the general. And then we can go ahead and get started. So I'm going to go to common interview questions. The last place that we left off was we were doing some integration testing. I showed you how to use Spring Data REST to create a CRUD in 2 lines of code. And by doing that, you can then use that as a reference for your own CRUD that you're designing and writing. And basically, if you can practice that over and over and over again, you will do very well on a job interview from the Spring Boot CRUD standpoint, like REST API standpoint. Like that right there is already a solid foundation for you to be able to get a job. And then there's 2 other topics that we want to cover. Java streams, always, never fails, man. You always get some kind of Java stream question. And then finally, never fails, there's always a SQL query question. So we're going to cover those 2 in the series. The GitHub link is in the YouTube videos as well, so you can always download this code too and just go through it. All right, so let's go ahead and get started. So the way this link is set up, if you look at it, they set up everything as tests. So what I'm going to do is I'm just going to go in here under the interview review package, and I'm just going to create a new package called streams. Wait up, no, I'm going to add a new folder. Yep, streams. What I'm going to do is go here to the test folder, and I'm going to create a new package called streams. And then from here, I'm going to create a new Java class called stream tests. Or how about stream examples? Stream example tests. And yeah. So let's go through the first one here. So on the left, we'll go through it together and then we can write code. So we'll go through this here. A guide to Java streams in Java 8 in-depth tutorial with examples. The addition of the stream was one of the major features added to Java 8. So this is huge. People still ask about this, which is surprising. They ask you, what were the major features? I guess they're too lazy to look for new interview questions. So a big one back then was, what are the major features that Java 8 introduces? And one of the big ones was stream. The other one was they introduced the local date time library. So they introduced a new time library and they introduced streams. And this in-depth tutorial is an introduction to the many functionalities supported by streams with a focus on simple, practical examples. Great. To understand this material, you need to have a basic working knowledge of Java 8, Lambda expressions, optional, and method references. Okay, I think we got all that. And Lambda expressions, if you don't remember, are anonymous functions, basically. First of all, Java 8 streams should not be confused with Java IO streams. This was a big thing. This kind of confused me when I first started with this. They're not the same thing. So whenever you see like file input stream or file output stream, like those are not the same thing as Java 8 streams. These have very little to do with each other. Simply put, streams are wrappers around a data source, allowing us to operate with that data source and making bulk processing convenient and fast. A stream does not store data, and in that sense is not a data structure. So this is key right here. It is not a data structure. It also never modifies the underlying data source. So the best way to picture this, a stream, is if you have an array of, data, okay, and you have like 1, 3, and 5, right? What a stream allows you to do, it's kind of like a faucet. So it's a faucet that will drip out a 1, and then it will drip out a 3, and then it will drip out a 5. Okay? So a stream is, they call it a stream because it's like water flow. And so when you're processing this array, it like iterates through each one, and it does a 1, then the 3, and the 5. Okay, so it's kind of like a baked-in for loop automatically. Okay, and that's the reason why they say that it never modifies the underlying data structure, is because it was designed to just spit data. That's it. Okay, and so imagine these balls or like these elements are coming out as a stream, right? You then tie them in to all sorts of operators, kind of like a conveyor belt at a factory, and then at the end, you get your end result. Okay? So a Java stream is kind of like a second programming language because it has a bunch of different operators and it allows you to manipulate a stream of data flowing through. Okay? And if you get really good with streams, you can do some pretty crazy stuff. Me personally, I'm not a fan of Java streams. I kind of like them. They're growing on me, but the problem with all of this right here is that how are you supposed to test this? So a problem that comes with this is that I think streams make it more difficult to test. Okay, so if you do a for loop, you're never gonna see me get mad at you or scoff at that, because it's all about high quality code, and high quality code is code that's tested. And if you're writing streams and you're not writing tests, then you can make the argument that that's not high quality code. Okay. All right. So let's go back. I think I've ticked off people right there already with that statement, but that's just my opinion. Okay. So does anybody have any questions so far on that?
So is it just like a bunch of set of operations that it comes with that's going to allow you to manipulate the data that you read,
Yeah.
get some sort of output?
Yeah. It's kind of
Okay,
like
so
it's a for loop on steroids, basically. But
okay,
it's a for each loop on steroids, basically. So you're going through every element, and then you can pass it through these different operators. Like if you have two different streams, like you have numbers and you have, or like let's say you have uh, uh, employees, and then you have like ID numbers, and you want to assign an employee to an ID number or to a team or something like that. You can make it so that you're streaming through both of them at the same time, and then you combine them, and then or like you can filter out different people, you can sort them. Like there's all sorts of crazy things that you can do that makes this way better than an actual for loop. Like when you actually go back and try to implement the functionality of a stream with the for loop, it's like 50 lines of code where you can do it in like 5 lines of code with the stream.
oh, so it just optimizes like
Yeah,
whatever task you're trying to do with the
yeah,
loop.
yeah. And but even then, I'm still hesitant about it because it can be very difficult to maintain, and it can be difficult for junior developers to come in and actually modify it. So there's like pros and cons to it, basically. Okay. So this functionality, Java util stream, supports functional style operations on streams of elements, such as map reduce transformations on collections. So map reduce transformations, map basically means you execute something on each element. That's what map means. And reduce means that you convert every element into a number or into a different a value. So what do I mean by that? Like if you want to get the sum of all the scores of the players, right? You would iterate through each player and then you would sum up all their values. That's what reduce is. Reduce is taking a list and then reducing it to a single value that you can use. Map, which I don't understand why the heck that they weird definition, weird word for this, but map just means you run an operation on each element and you're converting it from one data type to another data type. Okay. It sounds a little complicated, but once you get through it, it's pretty easy. Like, and definitely memorize what a map is. Memorize what reduce is. If you can do that, you're going to do well in the interview. Okay. So let's now dive into a few simple examples of stream creation and usage before getting to terminology and core concepts. Java stream creation. Let's first obtain a stream from an existing array. Okay, so right here, this is how you create an array. So let's go back in here to our test, and we've now have, shoot, we have an employee. No, dude, tell us what the class is for the employee. Okay, he doesn't tell us. What value is this?
It's like a number, or it's an ID, and then a name, and
Oh, this is how much money
It
they
might be
have.
a salary.
Yeah,
Yeah.
oh,
a salary. Yeah. So let's go ahead and create this method or create this model here.
It
So I'm
might be
gonna,
in billions though.
yeah, yeah. Let's create an employee class here, and we're gonna be using Lombok. So at data, and then what was it that they had first name? Oh, just ID. So we're gonna do. I'm not gonna do entity stuff because I don't want to actually make this a table. This is just going to be an example. So private long ID, then we're going to do private string name, and then we're going to have private double salary. Okay, so now that we have that, and then let's make an all args constructor, a no args constructor, and an all args constructor so that we can now, that code will work. Let's come back down here and let's import him, and this should work. Okay, good. Ah, it's supposed to be an int. It's all right. We'll do the int. Okay, so let's just make sure that everything's cool here. All right, we got this. So now that we have this, we can now go into at test public void. By the way, this is very dangerous to do it this way. If you ever write anything like this in a test, in a test class, I could do something like this: array of array of employees, 0 dot set ID to 4, like this, and I will set this employee's ID to 4 for every single test. Does that make sense? Like, if you set up something like this is extremely dangerous for tests because you can have state management issues. So the way to do this properly is to create a setup method, or a before each method, I'm sorry, before each public void setup. So stop me if you don't understand what I'm saying here. Actually, I'll
I think
just,
you've been going over this stuff in the past with
I
testing because
have,
you
yeah,
always got
but
a before each.
yeah, let me just go through it again. And what I'm going to do is I'm going to do an S out, and I'm going to S out array of EMPS 0. And when you run this test, you might end up actually getting, I don't know what. Let's see what what do we get. So I'm gonna X this. I'm gonna paste it here, and then let's run this. So we're gonna get 3 tests to pass, but you're gonna see that. Hopefully, we see that the ID for this employee is 4. Okay, come on. Okay, so let's see. Why is it running Spring Boot test? Okay. Whoa, that's weird. Why did it do that? Let me just run this real quick. Okay, so here we go. It showed ID1, ID1. Okay, cool. But then if I do an S out here, it should show me ID 4. Okay, so what's happening is we're getting lucky. Let me see what happens if I swap this out over here like this. See what happens. Nope. Huh. Okay. Well, I can't prove it, but I hope you guys see how this could potentially be dangerous. Maybe it's smart enough to, maybe it runs this static every single time, right? For each one of these tests, but I can't guarantee that. We would have to look into the documentation for this. But if you do stuff like this is where it can get very dangerous. Maybe we do this, take off the employee and run it. Let's see what happens. Or take off the static, I mean. Yep, same thing. So I don't know how it decides what on here, but that being said, if we're going to do this, what I would do is I would take this array of employees, take it out. So we declare the variable up here, and in the before each, this is where we actually enable it, like that. Okay. And in this way, you're guaranteed that you're reinitializing this thing every single time before a test. Whereas the other one is just confusing because you're not guaranteed. Basically, you're assuming that JUnit is smart enough to not or to reinitialize your static variable for every test, which I do not think you should trust that at all whatsoever. Okay. Can I move on? Are you guys cool with what I just said?
Yeah, I think that's straightforward because you want your tests to be independent of each other.
Yes, exactly. Yeah, 100%. You want your tests to be independent of each other. So you always want to reinitialize your stuff in the setup. Okay. So now that we have this, let's go ahead and go back to this. So stream of array of of employees. I'm going to rename to, no, I won't do that. Okay. So first test is getting a stream. So to get a stream, what you want to do, there's multiple ways of getting a stream. Java provides a lot of shortcuts for you. So you can do array of employees like this, and then you can do a stream. And so with IntelliJ, it helps you, it shows you how to actually do it. So part of the arrays library, it allows you to do arrays.stream, and this is all part of Java, by the way. Arrays.stream, and then here is your actual, the array itself. If you had a list, so if I have a list of employees, or employee list is equal to new array list, and I'm going to pass in array of employees like that, right? So by doing this, what is this guy not liking? Oh, what?
You can't like there's no constructor for that or
Okay. I guess, but what? That's so weird that usually you can just pass in the array and it'll do it. But if you do list of array, it'll actually make this an array. So if we then go in here and s out employee list like this, and then we run it, we will still get all three employees right here. Okay, but now it's in a list format, not in array format. And so because it's in a list format, a list instance automatically has a stream option. Okay, so if you do employee list dot stream, this stream operate. This is the first operator. The stream operator will then start passing through element by element by element into the rest of your operators. Okay, so these two lines are equivalent here. So employee list dot stream, this starts the faucet of data, and then arrays dot stream, array of employees, that starts your stream as well. So these are equivalent. It's just this one is for a list, this is for an array. Okay. We can also obtain a stream from an existing list. Oh, look, they're just explaining this. Arrays as list, array of EM employees, and then employee list dot stream.
that was
Note
the
that,
syntax they did right there. Is raise dot as list. You did yours differently, right?
yeah, I did list of. You can also do arrays dot
Yeah.
as list too.
Okay, I see.
There's multiple ways to do things in Java, which is kind of cool.
Yeah.
So list of is actually new. So arrays as list was a Java 8 thing, or at least back then. The list of thing is new. I don't know
Oh,
when they
okay.
introduced that.
Okay.
Okay. All right. So now we have that. Now that Java 8 added a new stream method to the collection interface. So collection interface. Collection is anything that is like a set, a map, which by the way is confusing because there's a data structure map, and there's also a stream operator map. But there's a set, there's a map, a list, a queue, anything that is considered a collection. You can actually it has the stream method. The instance will have a stream method.
Is there stack in this or no?
Yeah, you can. I think there's stack. I think it's I don't know if there's a stack or not. I think it's a stack queue or something like that. That'd be more important. No, maybe let me just
It's
take
not.
this. No, there should be. So yeah, there is a stack, but there isn't. I don't think there's actually. Oh, there is a stack. Okay, cool. Yeah, there is a stack you can use. I think the problem is that there isn't a queue. So if you do a queue, you're gonna have to put in your element, the type of element that you want, and then if you go to queue and you do a new queue, I don't think there's actually a new queue for you. You have to, yeah, you have to implement it with either a priority queue or a an array list. I think also
Uh,
works. So there's other things that you can use. There's other implementations for a queue, so you just can't do a regular queue. But if you
okay.
click on this, oh, you can use a linked list. Is there implementations on here? Well, you have to look up what the implementations are, but there are implementations you can use like a blocking queue, a linked list, and I forget what the other one was, but yeah. Okay, so let's go back to this.
You said it was just basically the various collections you're able
Mm-hmm.
to have a stream.
Yep, all the collections will have a stream.
Oh yeah, it says right there. Okay.
Yeah, and then it says, and we can create a stream from individual objects using stream of. So instead of list of, we can also do stream of. So we can do like stream dot of, and then we can have 1, 2, 3, and then from here, this is going to be a stream of integers. Okay, so let's go ahead and do one real quick. So the first one, let's delete all this stuff. Let's just do a streams of so that we can have this as an example. You can do, and by the way, you're never really going to use this one, but it's just as an example. Streams, was it streams of? Stream of, my bad. So stream dot of, and then let's do 1, 2, 3, 4, 5, like this. If you do this, nothing happens, okay? You need to connect operators to it. So what we're going to do is we're going to do a for each, and inside of this for each, we're going to create a lambda function, which is an anonymous function. And basically, we need to figure out what to do with each element. So I'm going to pass in the element, then I'm going to pass an arrow function, and then within the arrow function, I'm going to define what the operation is actually going to be for each of those elements. So in this case, I'm just going to do s out number colon, and then I'm going to print out element. So let me just write this element is like that. And then notice that element, so each one of these elements is injected into this variable. And then this code right here is what executes that variable. So when we run this, we should now get 1, 2, 3, 4, 5 with breaks in between them. So like it'll be 1, 2, 3, 4, 5 in column format. And there you go. This element is 1, this element is 2, this element is 3, this element is 4, this element is 5. Any questions on this? Please ask a lot because this can be really hard to wrap your head around.
So the
Okay.
operators are just gonna be function calls of the stream.
Yes, we can. Yeah. So it'll be like, so I'll give you another example. We can do something like stream of 1, 2, 3, 4, 5. But then what we can do is we can do a filter. So we will filter all the elements that are greater than 3. So element greater than
I
3.
see.
So this keeps all the elements greater than 3. So here it'll keep 4 and 5, right? And then we're going to we're going to link up all the operators together. So we can then do for each, and then we can
Of
then
those,
put all of this right here. So element like
so
that.
you can
And
use element again in the same
yeah, yeah,
because the name doesn't
because
really matter.
of scope, because of scope,
Uh,
like that. Okay. And so now when we run this, it's going to print out 1, 2, 3, 4, 5, and then it's going to print out 4, 5. All right, so let's go ahead and run this. So this is how you chain them up right here. So this is the big picture view. We're going to go into each more detail as we go through the site. But yeah, right here. So element is 1, 2, 3, 4, 5. And then this one, because we added the filter operator, the filter only allows those elements that make this true. The only thing, this thing, whatever makes this thing true, it allows them to pass. If it's not true, they're scrapped, they're rejected. Okay. And then once you get to this portion, all of the elements that pass this will now go through this for each, and then we print this element is, and so that's what this is right here. Okay. Any questions? Alyssa, how are you doing? You good?
So is this helping you for like implementing like all these nested loops by adding
Yes.
more operations? That's
You
all
can
it
do
really is.
crazy stuff. Yeah,
Okay.
you can do crazy stuff. Okay. So let's keep on going. You can also use Stream Builder. So I've never really done it this way, but let's go ahead and just show it. So you can do, let me just type it out right here. You can do stream.builder, and then you're going to pass in the data type that it is, and then you're going to call it employee stream builder. It's going to be equal to stream.builder, like that. And then you're going to go employee stream builder dot accept. I don't know. This is confusing me, but we'll just go with it. Array of employees 0. The syntax is, I don't know why it says accept. I don't know why it's not add. Did you see how that add came up? You would think that you would want to put an add, but there has to be something more to that. Once you do the accept, you can then do stream employee emp stream is equal to employee stream builder dot build. Okay, so it's using the builder design pattern. And then once you have that, you can then do employee stream. So now it's a stream. Now you can still run the same thing. Filter where employee, it has a salary greater, get salary greater than 150,000. Okay. And then we can then do a for each where we then print them out. All right. So then this will only print out Bill Gates and Mark Zuckerberg. It will skip out on Jeff Bezos because his salary is not greater than the 150,000. So let's go ahead and run that.
Those streams are like a new way to do loops.
Yeah.
I mean, I'm trying to summarize it a little bit, but is that too much of a summary, or is it?
Nope. It's a fad. No. I take that back. It looks like a fad up front, but the craziness that you can do with it, with the operators, um, makes up for its weirdness, basically.
Right.
Like
No, I can
you,
see how it's easy to read stuff,
yeah, and it's also easy to read
and
too.
yeah,
So yeah, as part of IntelliJ also helps you in showing you shortcuts. So like if you have like a method that passes a value in, it'll sometimes tell you that you can replace the lambda with the method reference. So this is a new thing in Java where you can pass in the method reference itself, and then it will then know that you want to execute this method. So like in JavaScript, you know how in JavaScript you can do function and then uh, function car is equal to, and then you have this lambda expression there like this. Well, car is the reference. The car is not only the name of the function, but it's also a variable that holds this function as well. The 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 reference to it. And so you can pass this car along to other spots and it'll know to execute that function for you. So I kind of make a joke that this is kind of like Java trying to be more like JavaScript. But yeah, it's very similar. Okay. So,
so
but
you're saying you're gonna do function calls within
yeah, you can if
your
you
the
want.
stream thing?
Yeah,
I
yeah,
see.
yeah,
Okay,
you can
okay,
if you want. So, but instead, we'll just do it this way.
got it. Okay.
Okay, so let's keep on going. There are other ways to obtain a stream, some of which will we see in sections below. Let's now see some common usages and operations we can perform on and with the help of the stream support in the language. So the first thing they cover is the for each, and I've already shown you the for each. But let's list a few things about for each. For each is simplest and most common operation. It loops over the stream elements, calling the supplied function on each element. So that's the key thing. It calls the supplied function on each element. The method is so common that it has been introduced directly in iterable, map, etc. And let's go ahead and copy this test and see what it does. This is the important thing right here. For each is a terminal operation. That means you cannot link up to it afterwards. Okay, so if I go in here and I write this test, so employee stream, what is this? What the heck did they? E.salary. They're like already adding. They're doing all sorts of. Okay, let's add this method here. Okay, well let me do arrays dot as or stream, and then employee or array of employees. Yeah, so then we don't need this dot stream anymore. So we're running our stream on the arrays here, on this right here, right? And then for each, we're going to do e.salary increment. So they take the employee, and there is a method on there called salary increment that we're supposed to execute, but it's not implemented. So let's go ahead and add that method here. And public void increment salary, and then we're going to pass in double and raise, and then we're going to do salary plus equal raise, like that. Okay. So I don't know if that's a 10% or not, but we'll just say it's, oh yeah, it is 10%. Shoot, my bad. So this is going to be the raise. So we're going to do salary is equal to, or times equal 1 plus the raise. Was it a, it's a 10. Okay, so we got to divide it by 100. So 1 plus the raise divided by 100. Okay. So basically, if 10 comes in, we get 10 divided by 100 to make it 10%. Then we add 1 to it, so it's 110%. And then we take the salary and we multiply it. We take the salary and multiply it by the 1.10 to get the new value, and then we put it back in salary. And so now that we've done that, let's assert equals, what is this? Yeah, assert equals employee list. What the frick are these guys? I'm getting confused here. Okay, let me just figure out all this real quick. Okay, we got all this down here, right? Okay, let's go back here. So salary increment, we got all this stuff. Where is that EMP list coming from? Assert that employee list. Oh, it's this. So contains, where are they getting the contains from? I don't know where they're getting the contains from. Import static method. Oh, cool. What is this? Is it a Juniper thing? I've never seen the. And then has property. Let's see what this is. Mattress has property. I guess it's a Hamcrest thing. Hamcrest contains, and then we should look for Hamcrest right there. Okay, let's see if this works. Let's run it. Okay, so
What
what
the heck is
they're,
Hamcrest? What's that
I
Hamcrest
have
thing?
no, I think Hamcrest is like a Makito thing, but it's in the cert, and what it's basically saying is that, oh look, it's an iterable. That's cool. So it contains. It expected Crusader Games interview review models employ.
What?
It's a reference to it. Let me see. No, it has all that data. This is weird. Okay, we're gonna. I don't know this, so we're just gonna figure out. We're
Was
gonna
it a
write it.
stream? Was that a stream though? When you put that in the assert, the expected,
Yeah,
because
I
you just
don't.
put the array.
Yeah, but that's how what they put. They put a list. Let me try the list. Let me just try the list real quick. So instead of array of elements of employees, we're gonna do employee list equal to this, like that, and then we're gonna do employee list dot stream. It's the same thing. We're streaming through the
Right,
same
right, right.
stuff.
Yeah, yeah.
Okay, but instead we're gonna put the employee list in here. Okay, and then let's see if this actually runs. I've never seen any of the contains or has property. I'm assuming that it's going through each element of the list and checking to see that there's a field called salary with this value. So it's kind of like a reflection. And it expected this list here, but it actually got an iterable contain. I probably used the wrong contains. So yeah, this is dumb. So let's just do
Is
this.
it the numbers? Is it because the numbers are off? Look at the way the numbers are. The salaries. They have longer
No, I don't think
decimals.
so. I don't think that's it. So let's do 110000, and it's going to be employee list dot get 0, like that, dot get salary, and then we can just go down the line with them. So this is going to be 1, and this is going to be 2, and this is going to be 222. This one's 33, like that. Okay, so let's run this. I might have to put a dot 0 there. Yeah. Oh my gosh. Okay, because this is a double, there is some error introduced in here. So what you want to do is you have to do a comma, and I think you have to do, let's see what this thing's saying. Uh, Here, float, here it is. Assert equals float, and then you put in your accuracy here. So we'll put 0001 like this, the delta. And then that way this test will pass. Because there are rounding errors. So just so that if you don't know a double or a float, this decimal is represented by a fraction of binary values. So it takes a denominator of 2, 4, 8, 16, or a combination of a value of twos. And these are all, and then it adds them all up. So like 1/2 plus 1/4 plus 1/16 plus 1 over 28 or 1 over 1 over 28. Like all of those fractions based on the bit values will give you a very close approximation of what the decimal is, but you as the deeper you go down, the harder it is to get that approximate get a very accurate value here. And so because of that, you have where you're expecting 110,000, but this one is 0.0001 different, right? And that will make it fail. So we're saying a delta here of 0.00001. We're saying it should be accurate to the 5th decimal place. So when we run this, we should now see that this passes. It's cool, man. This site is taking us to places that I never would have covered before. Okay, so any questions on this right here? This is pretty straightforward. This is the for each. Oh, I forgot to mention it's terminal, which means you cannot. So see how I cannot do an operator here?
Yeah, yeah. So
It
it's
just
asking you to
ends it.
do.
So here on the filter, if I wanted to, I can do another filter that says that e dot name get name dot begins or starts with, and it'll be j, right? So if I do this, then I do the for each. I'm going to print out all of the people that have a salary greater than 150,000 that starts with J, which I don't think that's any of them. Yeah, so there should be 0 people that print out for the employees. So streams are cool because you can actually link them up. You can link up different operators together. And you can see here, yeah, there's no employees printed because uh, the this filter has 2 people over 150,000, which is Bill Gates and Mark Zuckerberg. But when you get to, we're looking for all the records that start with J, then Bill Gates and Mark Zuckerberg are eliminated, and so nothing actually prints out. But if we put in an M here, it should print out Mark Zuckerberg. So let's go ahead and run that real quick.
So,
And
I'm like skipping
there he
forward,
is
but
right there.
you said these are hard to test for because why would if I have my code using these streams to do its operations, when I do a
These
test case,
are
why don't I just check for out?
these are simple ones.
Oh, I see.
But yeah, yeah, for simple ones, yeah, you can write tests pretty easily. You're good.
You get it expected and actual, and just compare
Yeah,
something
yeah,
like that.
exactly. You can do exactly just like we did right here. You're good to go on this. It's when you get to really complicated stuff, like when you're doing 10 operators. Oh my gosh. Some people will write that. They'll do like 10 operators in a row. They think they'll look cool. They kind of do look cool, but then you look at their tests and it's like, no, dude, no test. Come on, man. Or worse, you have to end up writing the test. Not fun. It's most likely you when you have to write the test where you're breaking something and you're like, oh my gosh, I got to write this test for this dude. Okay. So that's the for each right there, right? The next one's going to be the map. So let's do. So this is we're just going to put a for each here. Next one is going to be a map. So mapping is very similar to a for each. So I like that they put the map after the for each. A map is like a for each, but it's terminal, or it's not terminal. But the thing with the map is a map is intended to change the data type. So when they mean by mapping, they're saying like I'm mapping one value to another. Like if you let's say you have 2 classes, right? You have an employee and then you have a person. So like here you have employee and this is you have a person. So if we were mapping person to employee, you would take the first name, the middle name, and last name and probably concatenate them all together, right? So you have the first name, middle name, and last name in one string, and then you're going to put that in the name field. You'll probably take the ID and put it into the ID field of the employee, and then the salary you're probably gonna have to figure out something, right? There'll be some method that'll help you calculate what the salary is, and then you calculate it for them. So the act of converting one data type to another data type is called mapping. So I'm assuming that's why they did call it map, but to name the operator map is that's what gets me confused. So it's like, whoa. I understand that they're using it to map data from one data type to another. I did not like the name of it, especially because there are also hash maps, right?
Yeah,
Other
maybe
data
another
structures
better
of
word,
maps. So yeah, please use another word, but
like convert or something. I don't even
yeah,
know.
exactly. But they like the word map. Okay, so public void map. We're gonna do. Let's just see what this guy's test has. Well, we can actually do the example with our thing. So we're going to do a test here. When map ID to employee, then get employee stream. Okay, it's a weird test name. Oh, these are the employee IDs. So they're mapping the employee IDs. So list of employees equals stream of employee IDs, which is this right here. And then we're going to map the employee repository find by ID. Oh, wow, this is cool. This dude, like, he has examples, but none of this stuff
Are you sure
works.
they're not missing the classes for all this stuff? Like,
I don't know. I'm looking at it. There's no GitHub or anything like that. He's just assuming that you have a repository set up. All right, that's fine. So what he's doing right here is he's taking the employee repository, finding it by the ID, and if the ID is found, then they collect it. And so they're basically converting the 123 into an employee. Let's use a different example. So what we're going to do is we're going to create a new person. So let's do like that, right? And then we're going to put in our here persons is equal to new person array. And then in here, it's going to be a new person. And please tell me we have, yep, we have ID of 1. We have a person DTO. So new person DTO. Please tell me we have fields here. Nope, we do not have fields here. So let's just add them. No args constructor, all args constructor. And so in the person DTO, we're going to have a Jeff, null, Bezos, and then we're going to have some year, right? So should be like local date of. Okay, and then we should then have the phone number. So 555-5555. Okay, so we have this person here, and it's supposed to be a long. And then let's go ahead and add the other people too. So 1, 2, 3, and then this guy is going to be Bill Gates. And this one is Mark Zuckerberg. And to make it easier on ourselves, let's make these empty strings. What? Why are you letting me? Okay. So we have empty strings for the middle names. And Jeff Zuckerberg. Okay. Let me just fix all this. We got to put our commas in there. Good. Semicolon. Oops. Over here. Oh, that's, there we go. Comma here?
You want to put Mark for Zuckerberg instead of Jeff?
Yes. That would have hurt our example here. Okay, so what are you not liking? I'm missing some. Oh, I'm missing another parentheses. No. New person DTO. Oh, I'm missing a bunch of parentheses here. Okay. All right, so we good here on this? We're just creating an array of persons now. Okay. And then in here for our test, we're going to make list of person, or let's do arrays of arrays stream, and then we're going to do persons. Okay. And then for this, we're going to do a map. All right. So we're going to do a map. And inside of this map, we're going to take our person, and then we're going to do a specific action to it. So the action that we want to do is create a new employee. So employee is equal to new employee like this. And then what we're going to do is employee dot set ID to person dot get ID. Notice how I'm not trying to get fancy. I'm just writing, because I have these curly braces, I'm just writing regular code in here. And we're going to have to typecast this to an int, which is dangerous. Oh my gosh, it's complicated. Cannot cast long to int. How about integer? Come on, let me. Cannot convert long to integer. Shoot. So let's do it. Let's change this employee to long so that we have. The reason you can't convert from a long to integer, can anybody tell me why?
Is it the size of the byte or something? Try
Yeah,
to
it's the
represent.
size. You're not guaranteed that you will actually be able to
Does the long
convert.
class not have a function that just gives you an int, or is that
The long is really big. It's twice the size of
but
an
the class
integer.
long? What methods does the class long have? Because I haven't
Uh,
used one.
long dot parse long.
Uh,
So there's other things you can use there if you want.
I guess not. Never mind.
It's all right. This is better. So now that we do this, now we're going to set the name employee dot set name, and then we're going to do person dot get first name plus space plus person dot get middle name plus. I don't know if we should put a space or not. Let's just put a space. No, we won't put a space. Person dot get lat. We're gonna actually. So if you really wanted to do this intelligently, you would have to figure out how to put all of these together. Oh, we can do that. So we're going to do employee. So employee dot set name, and we're going to do string dot join parentheses. No, you can't do this either. I was thinking of doing something like this, and then you would do list dot of, and then you would pass in your elements of person dot get first name.
Oh, is
But
that to avoid like double spaces if there's a
yeah,
middle
but
name
it's
or
still
something?
going to give you a double space. Dang. Well, we'll just leave it like this. All right, and then well, we'll leave it like this. It's too crazy to just it just complicates the code. All right, and then we're gonna do employee dot set salary, and then for the salary we'll just put in 20,000. Okay, for now. And then what you want to do with the map is you have to return the new object that you're creating. Okay, so you have to do return person like this. And what this does is when you stream through the person. Oh, sorry, return employee. So when you're streaming through persons, you map it, and what goes in, out's going to come out an employee. Okay, and then what you want to do next is you want to collect it, and then do a collectors to list. And so once you do that, this puts it in. This converts it from a stream back into a list. And so now what we can do is when I do employees like this, and I try to create a local variable, it's going to know exactly that it's a list of employee. Okay, and the reason I knew that is because this map is passing in a person, but it's returning a data type of employee. So it knows that you're going to have a list of employees as your final result. Okay, and then here in the example they do collect collectors.toList, but here IntelliJ is saying we can do it another way. We can replace collect to list with to list, which okay, that's fine too. So now that we've done that, we can now print out what's inside the employees, and let's also print out what's inside of persons. Okay, so now when we run this, you're going to see Java incompatible type. Oh, it's because I messed up here. Let's put an L here, put an L here, put an L here. Let's rerun it. Maps are pretty cool. You're definitely going to get uses out of maps. Okay, so there you go with your map. Maps are also good if you want to convert DTOs into your database objects or your model objects, or if you want to convert models to DTOs. They're very, very helpful with that. So right here, our person does not have a toString assigned to it. So let's go back and fix that real quick.
Is that Lombok? Oh, isn't that data does not give it a thing or?
Yeah, I thought it did. Why the heck is it? I guess let's just generate it. I don't know why. Let's generate a toString. Here we go. Yes. Okay, let's rerun it. Yeah, it's still not doing it. It's because I guess it's an array of persons. Jeez Louise. Let's see if that works. It's kind of dumb, Java, that you would not use the toString of each object, but let's see if this works. Arrays toString and then persons. Okay, there we go. Now we got it. So now if you do arrays.toString, it will call the toString for each of the elements in here for this array. So that's what that is right there. Okay, and so what you can see here is that you have the first person with Jeff, middle name Bezos, then Bill Gates, and then Mark Zuckerberg, right? And we converted each of those persons into a new employee record of ID1 named Jeff Bezos, salary 20,000, employee 2 Bill Gates, salary 20,000, employee 3 Mark Zuckerberg, salary 20,000. Does that make sense? Are we cool with that?
Makes sense.
Okay, and now if we really wanted to, I can show you some cool tricks with map and all the operators. If you do a comma here, you can actually pass in the index, I think. So let me see if I'm doing this right. If not, we will. Oh, it's saying wrong number. I guess that's a JavaScript thing. My bad. Okay, so there's person right there. Because in JavaScript, if you wanted to, you could pass in the index, and you would then, it would treat it like a for loop, and the index of each element can then be used inside of the code itself, which I was going to try to use to figure out the salaries for each of these guys. But I guess
So like if you would do like if index is some number, then you can do this.
no, I was just going to do index times 100,000 or index
Oh,
plus 1 times 100,000, and then that way it'll automatically map out each of these salaries properly.
oh,
Okay. So that's that one. So let's go back to this right here. So what they were doing is they were mapping a list of IDs and they were streaming through it and they were going to the repository and finding by ID. So they're converting an integer into an actual employee data type with this. And then they did the exact same code that we did. And they were able to assert equals that the employee size matches the employee ID's length, which we should probably do the same thing here. We're going to do assert equals that that person's dot length is equal to employees dot size. So we're testing that the size of our employees matches the known length of our persons. So when we run this, this should pass. Okay. All right, cool. Next one is collect. We saw how collect works in the previous example. It's one of the most common ways to get stuff out of the stream once we are done with all the processing. So in the stream, you just call, remember, so here it's in stream format, okay? And then when you do dot collect, collectors to list, there's other collectors as well. You can collect it as a map or other things. And then from there, you can then, it'll then become a list data type. And the assert equal, and then so, yeah, that's good. Oh, look, they're doing assert equals of the employee list with the employees. And what's good to know, employee list is not modified. You have to understand this. Employee list is not modified, okay? Employee list will still have all the employees. If you modify a property inside one of these objects though, yes, that will be modified. But if you're doing like sorting or you got to be careful. If you're using a stream and you're doing operators, then you're not changing the actual list itself. The only time you do change things is when you change the individual objects themselves. Okay. So let's do an example here. So if I go to the filter here, right? So if I do stream of 1, 2, 3, 4, 5, and I filter all of this out, let's see what we can do here. let's go here. So employee list is equal to new array list. We're going to the map. Oh yeah, let's do the map here. So the map is going through the persons is going through this entire thing. Yeah, I mean, and I proved it right there. We print out persons. Persons doesn't get changed. Persons is still persons here, right? It doesn't. There's no employee records there. It's just persons, and then employee is then created off of the person, and it's a whole new version of it. It's a whole new copy of it. So I'll give you another example. Let's say we now do this. Oh, by the way, you can do this too to organize your code. Let's do P. And inside of this, we're filtering all the people that start with an M, right? We'll do another Mark Zuckerberg. Starts with M, like this. So now we should only get a list of one. This test will fail now because we're only getting Mark Zuckerberg from all of this. So we go ahead and we run this. There you go. It failed. Why? Because it expected 3. It expected a size of 3, but it only has a size of 1. It's because Mark Zuckerberg is the only one that was converted to an employee. Okay? But if I go back and I print out persons, which I did here, you're going to see it was not modified at all whatsoever. It's still the same thing. So let's do another test. We're going to do arrays.stream persons. And then we're going to do arrays.streams persons. Then we're going to do for each, right? And then we're going to do p dot set first name to John. And by doing this, you're not, see, the person's reference is protected, but the objects are not protected. You can modify the fields in the objects, and that memory address will be, the data at that memory address will be changed. So let's go ahead and run this, print out persons, and we'll see that they should all be to John. And you can see now that first name's John, and first name is John. Does this make sense? Are we all good with this? It's kind of tricky.
No, it's making sense.
Okay. Anybody else that it's not making sense to? Let me take out this filter so that our test passes, and then we can continue. Okay, let's go back to the guide. We talked about filter, so the collect so let's do another collect right here, right? So now that we have all of this, let's do employees again, dot stream, and let's do collect. Oh, shoot, I don't know collect that well. Ooh, we can do a set. So we can then collect it as a set. So we can then make a set. So notice we are not changing this. We are creating a whole new data structure for this. So now I'm going to do set employee, and it's going to be employee set is equal to that. So now by using collectors to set, I'm taking all the elements and putting it inside of a set that I can then use in the future.
Are there various sets like a hash set or something like that?
Yeah,
Or
yeah. Well, a set is an interface. Hash
interface, right?
set is
Yeah.
the way you want to use, is the implementation of it.
So when you run this collectors to set, are you getting like a hash set of it, or what kind of set?
I don't know. That's a good question. So let's do employee set dot add, and let's go ahead and add employee list employees dot get one. Okay, let's see what happens. It might give us an error saying that you can't write to this because it's a read-only set. So there is a way to fix. Oh, it did work. Okay, great. Or maybe it ignored it. I don't because a set you can only have one element of the
Yeah.
same type in the set. So I don't know if this is a valid test because it's going to ignore it no matter what because it already exists, right? So let's see
Right.
if I do a new employee.
Well, I don't even know how many different sets are there that Java gives you.
I think there's just a hash set,
It's just
or
hash. Oh,
but
maybe
I
that's why.
don't. That's the most famous one. I don't know. That's I don't. I take that back. I don't know. Hash set's the most famous one though, and that's the one that's. I mean, that's most commonly used. Okay, so it didn't add it. Wait up. We have to print it out. My bad. Let's print it. Let's print it out. Let's see what it is. And yep, it added it. So it's a working set. It's. I think I'm pretty sure it's a hash set. So
Okay.
let's do. Oh, let's do. We're gonna print out instance of. So we're gonna do employee set instance of hash set.
What does that do?
This is gonna return true or false if this is an actual hash set or not.
Oh, okay.
So let's go ahead and run this. So this will answer your question if it's a hash set or not. Yep, it's a hash set.
Oh,
Cool. Okay, so that's so collectors basically the takeaway from collect. This is can get way more advanced. The thing that you want to know with collectors, it puts it into a data structure now at that point. So a stream is not a data structure. When you to be able to put it into a data structure, you need to do a dot collect and like look over here, collectors dot to unmodifiable list. That's kind of cool. So if I do this, then so what does it mean by unmodifiable list? It means a list that. Let me take this out. Let me put that back. It means a list that you can't remove or add stuff to. That's all it means. You can still change the it's kind of misleading because you can still change the properties of each of the employees, but you can't like change the order of the list itself. And this one is to unmodifiable list right here. There you go. So now if we do unmodifiable list.add new employee, this should now break because it's going to say, nope, you can't modify this list. Yep, there it is. And it's unsupported operation exception, immutable collection. What this is saying is you can't modify this list.
cool.
Okay, so that is collect. Shoot. Let me just make a collect test. Gather different data types. Okay, and then let's just take all of these. Okay, and then here we can take out this. Set employees, we don't need a set of employees. Persons, yep, this is good. Okay, so we run this test. This should pass still. It's going to print out that it's oh, we can do an assert true that employee set instance of hash set. Stream should return a hash set. Okay. Let's go back. So we already covered filter, right? Yeah, we already covered this. Collect performs mutable fold operations. Mutable fold operation sounds very, very confusing, but you guys saw what we did. It just tries to put them into a data structure for you to continue to use. Repackaging elements to some data structures and applying some additional logic, concatenating them, etc., on data elements held in the stream instance. The strategy for this operation is provided via the collector interface implementation. The example, so collector interface implementation. So you can actually write your own collector or implement your own collector interface to to create your own data structures, basically. In the example above, we use the toList collector to collect all stream elements into a list instance. Next, let's have a look at filter. This produces a new stream that contains elements of the original stream that pass a given test, specified by a predicate. So a predicate is a good interview term. Can anybody tell me what a predicate means? I'm hoping, Mayor, you remember what it is. I don't know if we have
Oh,
Sam on here.
he's not here.
Oh, okay.
They're both gone.
Oh, everybody's gone. It's just me and you.
And
Oh,
McConnell.
McConnell. Nice. All right. McConnell, this should definitely help you out with the interviews that I have coming up.
Okay.
Predicate. What is a predicate? Anybody know? Predicate is a fancy word. It's a scary sounding word, but all it is, it's a method that returns a Boolean. That's it.
Oh, okay.
So when they say a filter, this produces a new stream that contains elements of the original stream that pass a given test specified by a predicate. What it's basically saying is you need to give the filter a method that returns true or false. And so when you look at the example here, we already did this example basically. But if you look at this test here, they have employees 1, 2, 3, 4, their IDs. They stream through it, and then they run the map operator on this, which means that they are converting the employee IDs to a ID, and then they filter anything that is not equal to null. So if an employee was not found by the ID, they filter them out. And then over here, they filter out, or they filter them out, which means they remove them from the list. Okay, so this has to be true to keep them. So the thing to remember with filter, true keeps them. You have to remember that. Filter, true keeps them. Okay, so this right here is looking for things that are not null, so it keeps them. And then it looks here for all employees that have a salary greater than 200,000. So anybody over 200,000, it keeps them, and then it collects them. It's pretty
So
sure.
so the name should have been at least employees with $200,000 salary or something like that. Instead
What's
of just
that?
employees. The name of the employees for this value, like, is doing all these operations, but it's converted to a list, right? But it's just called employees. In your code, wouldn't you want to call it like employees that have salary over?
Oh, yeah, if you wanted to. Very good. Trinity would disagree with you. Trinity would call it cars instead of employees. I wish she
What?
was here so she would hear that joke, but
Okay.
yeah, that'd be a better name for it. Okay, in the example above, we first filter out null references for invalid employee IDs, and then again apply a filter to only keep employees with salaries over a certain threshold. Yep, so I just glazed over me reading my own stuff. We filter out the null references, right? And then we apply a filter to only keep the employees with the salaries over 200,000. That's all they're saying. Okay, next one. Find first returns an optional for the first entry in the stream. The optional can, of course, be empty. So let's just start out with this right here. So we're going to do a find first. Find first is basically get the first thing that matches all the criteria. And so we're going to do a find first here. And it's supposed to return an optional. So if we do employee IDs 1, 2, 3, 4, right? And then I do employee IDs dot stream. No, cool. It already automatically knows. That's crazy. We're going to do this dot stream, right? But if I do a find first, what's going to be returned is an integer. Okay, and so what should come out here, oh, it's going to be an optional. So we're going to do a dot get. So we're going to then do assert equals one value. So value is going to be equal to a 1. And the reason I know this is because all we're doing is we're just going through each element one by one, and then we just say, give me the first one. So find first gives you the first one, which is a 1, and then it puts it inside of an optional. So the optional, so let me take this out so that you guys truly see it. Optional integer, and it's going to be the optional here. And then I'm going to make integer value equal to optional dot get like this. And so that I already know there's going to be something in the optional because there really is no criteria. It's just you give it the first one, it finds it, and then it returns it. So when you run this, it's going to pass. Okay, but we can do more advanced stuff with find first. There you go, it passes. So what we can do now is we can do arrays. We can go through it again. We're going to stream through employee IDs, but this time we're going to filter if they're even. So we're going to filter out ID mod 2 equals 0. So we want we only want the even IDs from the filter, but then I'm going to do a find first. All right. So I'm going to do optional integer even ID optional is equal to this. And then I'm going to integer even ID is equal to optional dot get, right? It should be a 2. And then we're going to assert equals that it's equal to 2. Okay, so now when we run this, there you go. Whoa. ID mod 2 equals 0. ID is 1. 1 mod 2. 1 mod 2 is 1. Oh, it's because I did the wrong one. My bad. It's supposed to be even ID optional dot get. Okay, so let's run that. This should pass. Yep. So it found the first even one, and it's a 2, and so that is what get executed. And then finally, let's do another optional, and it's going to be optional 3, or let's just do optional C is equal to arrays.stream, and we're going to do our employee IDs, but this time we're going to filter by things that are greater than 10. So we're looking for IDs that are greater than 10, which how many of those are greater than 10?
None, right?
Yeah, so when you find it first, when you do a find first, and you try to put this inside of an ID, this should fail now. This dot get should fail. So when we run this, it's going to tell us, yo, you can't get, the optional is empty, the bucket is empty, you can't get anything. So right there, no such element exception. So it purposely throws an error because you're not checking that there's something in there. So what we really want to do is we want to do an assert true that optional C is empty. Okay, so if optional C is empty, or optional C should be empty because there's nothing that matches the criteria for this stream. Like it ends up being empty at the end, so find first ends up being empty, so it returns an empty optional here. So that's how find first is useful. And if we want, we can even do this, assert true, and this one is going to be even ID optional is present. So if because there's something in here, this will be true. And if we take this and we put it up here, we're going to see that the optional is also present because there was actually a number in there. So when we run this, These will all work. There you go. Cool. Any questions on that?
Straightforward.
It's very straightforward. Okay.
Yeah.
The next one is going to be toArray. So let's do toArray. I have trouble with toArray. I don't have it all memorized. So let's see if we can learn it together. Convert toArray. So the way you have to do this is we're going to start with our employee list. There, let's do list employee. Employee list is equal to new array list. And inside here, we're going to put our array of employees. Which I don't know why you can't just do, so we're just going to do list of like that. I don't know why you can't just do new array list. Okay, so this is our list of employees. Now we're going to stream through them. And then we want to convert them back to an array. And all you got to do is toArray like this. But then you can't just do this. It doesn't work like this, I don't think. So let's do employee array is equal to, yeah, it doesn't work this way. I don't know why it doesn't work this way. That's how you would think that that's, but so what they're saying here is this is an object. You need to specify what data type this is supposed to be. So the way they do that is you can do it like this: new employee, bracket like this, put a 0 in there. Nope, not that way. New bracket, and then this should work. Okay, that's not working. Oh, that's not an anonymous function. Sorry. What? Okay. No, that doesn't work. So toArray. So
Well, you just look at the example. Does the
I know.
example say?
I don't. It ticks me off.
You don't want to cheat. You don't want to cheat.
I
You
don't
want
want
to
to
say,
cheat. I don't want to. I want to actually try to figure it out. So
what
they
the
just,
hell? Employee bracket new?
yeah. So they just call the constructor.
Oh,
Yeah, they're
that's
just
a
calling the
that's a
constructor for that.
that's a way to.
Yeah,
That's
remember
a,
how
what was that? What was that called? What is that called? Like a function thing, or what's the double?
it's called can be replaced with, no, can re nope, that's not what it was. It was the S out. Yeah,
Yeah, it
right
was
here.
SL.
Can be replaced with method reference. Oh, it's a method reference. So you're putting the method reference of that colon new in here for an employee array. So you're calling the constructor for an employee array. So the toArray is taking the reference of the array constructor that you want to use to create your array. That's how it knows what data type to use.
Is that almost like that pointer stuff?
Yeah.
The pointer. Well, it's a type of reference pointer or something. I don't know.
Yeah, it is. It's pointing to the function. It's pointing to the constructor method. Okay, that one's it.
Oh, it's pointing to the constructor method of the employee
Bracket. Yeah.
bracket. Oh, okay.
Okay. So. Okay, the next one is, so there's not really many questions. Like this is like you just need to. You don't even have to memorize the syntax. You just got to know how to reference it. I guess you should memorize this. You don't waste your time. But like, yeah, this is how you would do an array. I bet you. I mean, there's others. Let's see if there's any other things you can do. I could have sworn there's another way of doing it. toArray. Yeah, you can do a toArray. Like you don't even need to do a stream. You can also do toArray here like this. But the way you do this one is you do new employee. New employee bracket, but inside the bracket you put a 0. So it's like you're telling it, I don't want you to allocate new stuff. It's already been allocated for you. So you do new employee 0 and then you pass it. Like that. And then if we assert that they're equal, they should be equal.
What's with the 0 there? What? Why does it have to be?
Because the number that you put in here tells you how many elements you're allocating. So if you put a 0 there, it's basically it's like a
All of them? Is that
shortcut.
saying?
It's like
That's saying.
it's like saying the shortcut. Like I want you to do it for all the things in this list.
But
If
you
you
just
did
put
this for real
one,
though, yeah, if you did this for real on regular code like this, you're basically allocating nothing there. And there's 0 elements, and it'll be like that forever. You get what I'm saying?
yeah, that is no
This
elements. Yeah,
this
you
is no
can't.
elements. Never. You can't make it grow. Nothing.
Right,
This
right.
will allow you to add the elements from the list already in there. And there's some that's kind of dumb, but there's also examples where you can do employee list.size, and that will also work.
Uh,
But that actually makes more sense. But I don't know why they put a 0. I've just seen that a lot,
Okay.
where it works with a 0. And let's see if this actually works or not, because they're different references. They're different employee array address. Yeah, see, they're different references. So that's why it didn't work. Cert equals, is there a cert equal arrays?
I thought you would do like a 2-string for each one, and then just
Okay,
compare.
okay. Let's do that. Let's do that. This also makes sure that they're in order, right? So let's run it. Let's see if it works.
Oh, does it? I mean, I guess.
Yeah, if employee array 2 is in a different order than employee array, it won't match because the strings will be in different locations. That's awesome. Good job. That's great. GG, man. Okay, the next one is the hard one. I still get very confused by this. Flat map. This can be on interview questions. I've seen it. I usually screw it up. Hopefully you guys don't screw it up. Okay, so flat map, how to, helps us to flatten.
Where's
Okay.
your screen? Where's the thing?
Oh, I'm sorry. It's right here. Flat map. Let me read it. A stream can hold complex data structures like stream, list, string. So your elements will actually all be strings, basically. So in cases like this, flat map helps us to flatten the data structure to simplify further operations. So when flat map employee names then get stream, inside of here, they're going through the list, collection stream, collect collectors to list, names flat stream dot size is names nested size times 2. Why? What? Notice how we're able to convert the stream list string to a simpler stream string using the flat map API. What? Well, let's try to figure it out ourselves then. So let's create let's create some numbers here. So we're going to do integer of EMP IDs. So it converts to a list.
What's up, Trinity? No, I don't.
Trinity was there.
Trinity's up here upstairs.
Ten. Okay, and then next one is integer bracket EMP IDs 3 is equal to 20, 30, 40. Okay, I'm purposely picking numbers that are not the same so that we can try to put them all together. So then what we're going to do is we're going to do, oh, I see, they did arrays as list. So we're going to do list of integer array. So we're going to do list of arrays is equal to arrays.as list, and inside of each of these we're going to pass an EMP IDs, EMP IDs 2, and EMP IDs 3. Okay. So we're all good here. So we're making a list of a list. So each element of the list of arrays has EMP IDs as one object, EMP IDs 2 as another element, sorry, and EMP IDs 3 as another element. All right, so if we try to print this out, it's going to look like grouped numbers. But we don't want that. We want to make sure that everything is, we want to extract all these numbers and put them all into one list. Oh, you gotta be kidding me. I don't even know if this will work. Let's try it out. Yeah, I don't think that's going to work. Shoot. Okay, well, you can see right here that it's printing out array 1, array 2, and array 3. All right. So what we want to do is we want to go through this, and the flat map will let us break it all down. So list of arrays dot flat map, stream dot flat map. And what does the flat map do? The flat map is saying collection stream and then to list. Shoot. I don't know what, there's got to be more to this. Sorry guys. So we're going to do a stream, flat map collection stream dot collect, and we're going to do our to list here. And then what we're going to do is just do a for each and then just print out each element. No. Let's actually get the list. So what are we missing here with the flat map? Come on, give me what are we missing here? This guy says collection stream.
What's supposed to be in there? Predictable?
I don't know. A predicate?
Wait, I don't have her.
Huh?
Oh, she's right there. Trina's looking for Zoe.
Oh. Okay, I'm going through this real quick. So map and flat map API sent from functional languages. So how are they doing this? S optional of string.
You think Sam and Maha already know about streams, and that's why they bailed?
I don't know. Okay. Yeah, this is what confuses me. I don't know.
Go back to the example real quick. Is it saying that it makes the strings become? Go back to the example in the page. Let me see what that shit said.
Yeah.
So I can see what the hell. So they have space. They have Jeff as one name, Base as the last name, and then it says you're gonna assert that the size is 2 times the size. So it's gonna make
6. So
it's gonna have
there's
7
3.
Bezos, Bill Gates, Mark Zuckerberg,
No,
all
it's
in
gonna
one
have
new
Jeff.
list.
It's gonna have in one list. It'll have Jeff Bezos, Bill Gates, Mark Zuckerberg.
Oh, it'll be 3.
It'll be one list, 6 elements.
Yeah, that's what I'm saying. So each string is gonna be an element in this new list. So there's 6 of them.
Yeah.
Names nested.
Yeah. Names nested has 3 lists. So
3 elements.
names nested is a list of lists.
But names flat stream is gonna have. So it breaks up.
Yeah. Let's just copy this test because it wasn't the collections thing is not working. Oh, it does work. Oh, it's because I was putting collections. Gosh dang it. What? Oh, is it because it's an array? Shoot. So
You
what
can't.
I need to do is I have to do an array So basically element, so each element's an array, right? So I can just write, you can write whatever you want here. I'm just going to write array because it's more descriptive. But in here, I want to do arrays.stream.
The stream of that thing.
Yeah, the stream of the array itself. There you go. Now that works. So flat map takes a stream. So the flat map, this now makes a lot more sense. This is, dude, I have not understood this for a long time, but this now makes sense. The flat map takes a stream of your list and then like adds it or makes it a faucet at that point. So what's going to happen is it's going to go 1, 2, 3, 4, 4, 5, 8, 10, 20, 30, 40.
Yeah, yeah. It's gonna give you all the elements in now one big list.
And it's going to be in order. So when we print this out, it should be 1, 2, 3, 4, 4, 5, 8, 10, and all that. So let's run this.
Because it's the order of the, okay, yeah, your actual.
Yeah, it runs the first element. It does the first element first, then the second, then the third.
Yeah.
And 1, 2, 3, 4, 4, 5, 8, 10, 20, 30, 40. Yep, that's it.
I see.
Awesome. Okay, so this makes it a lot less intimidating. The flat map just requires a stream of the element itself to then pass it on. That's cool. So check this out. If I put a filter here, I could have issues here, right? Can you tell me what the difference between this filter is and a filter over here on this side would be?
So you're gonna filter from the list, your original list first.
Yeah.
You'd have to pull from, how are you gonna filter? Like
exactly. Every list
Size?
is now an array in here, right? So L is so if I do a filter here, L is going to be a list. So I have to be
It's gonna
filtering
be
off the list itself. But if I add the filter afterwards, I am now filtering by each element, which could probably be a little bit more helpful.
Yeah, because they're trying to go through all the data that's from all those arrays, and then you just want to filter from there.
Yeah.
I see.
Yeah.
Okay.
Cool. Does anybody have any
and-
questions?
And
Yeah,
you're not modifying any of the lists or anything like that. That's why this is useful, because you
Yes,
can do this manipulation without breaking shit.
exactly. I like the word that you used there. You induce manipulation without breaking, and then you went shit.
Yes.
Okay. All right.
I won't say that in an
So
interview, but yeah.
you probably would say it in an interview. Okay, let's see what's going on here. So flat map, that was the hardest thing, I think. We got flat map now. We're good.
What's the peak? What was that? The
Let's
last
go.
one?
Yeah, the peak. That's not the last one.
There's not the last more of
It's
these
not
shit?
the
Oh
there's,
my
yeah,
god,
there's so many of these.
There's so many more things.
Min, max, distinct. All these are cool though. These are cool. Maybe we can cover them real quick.
No, I want to watch Terminator 2. What is peak real quick? What the hell is peak? Is that
Okay,
anything
we'll
useful?
end it at peak. Because we've already covered a lot. We can end it at peak and do Thursday.
Isn't it just you find the biggest one and burn your list?
Hold on, who is this? Who's speaking? McConnell?
That's Big Mac.
Me.
All right, cool. I didn't recognize your voice on Discord. Okay. Peak is I don't know if peak's the biggest one. I think peak is it's looking at the item first, so you can do something with it. So we saw for each earlier in this section, which is a terminal operation. However, sometimes we need to perform multiple operations on each element of the stream before any terminal operation is applied. Peak can be used useful in situations like this. Simply put, it performs the specified operation on each element of the stream and returns a new stream which can be used further. Ah, shoot.
Peak
It
is an
returns a
intermediate
new
operation.
stream. So it's kind of, I think it might be almost like a flat map. Well, let's check it out. When increment salary, so let's just copy this test and run it. Okay.
Is an intermediate operation just the opposite of a terminal? That means it has to be done.
It's done in the middle, and which means it returns something. Does it allows you to link it basically. Intermediate means you can link it. So I'm just gonna S out. Yeah, they didn't even put in a variable. Why didn't they put in a variable? So let's just put actual
Yeah,
list.
yeah, yeah. Where do you collect them to?
Okay, and then let's just S out actual list. And I don't know what.
Oh, is it because they're just changing the values in the actual?
Oh, maybe. Yeah, because they're incrementing the raise. So let's actually see let's see what happens. So they should be the same thing. They're taking this for each of them,
Yeah.
and then they're adding a raise. Oh, so basically all this is, in Angular observables, there's a thing called tap. But basically what this does is it lets you do something with an element, and then, but it brings you back to the stream. So when it's saying it's returning a new stream, that's scary. It's not. What it's doing is it's basically saying like, yeah, you can now do a dot. It's returning a stream in the sense that if I hit a dot, I can do more operations. Whereas if I had dot for each, I'm not returning a string, right? So if I do a dot after that, there's nothing available after that because for each is terminal.
Terminal?
It finishes the whole thing.
Yeah, yeah,
Okay, so here we can then peek. We can then do something like s out print line. I don't like how they do that because you can't.
They're doing two different peaks. They're doing. Oh, you can
You
send in
you
peaks.
can't set any parameters. So let's just do e dot, or let's just do s out e dot. Let's print the salaries. So when we run this, we're going to do the salary increment. Then we're going to print out e. Then we're going to then print out the salary itself. So I mean, and there's you could do a lot of stuff with that. I mean, I guess it's all right. I really haven't seen peak being used
So why would you have to do collect list at the end if you were just going to modify
because it's a
values?
stream. So this right here is now a stream.
Yeah.
So I have, like, I'm in
You
a
need a term.
different
Oh,
mode.
you need a terminal to
Yeah,
to
I need a
evaluate.
terminal to make it to convert it back to a list. Because right now I can do a filter, I can do a reduce,
I
I could
see.
do all sorts of stuff. A find first. It doesn't. It's in the wrong like paradigm. You need to do the collect so that you can like. You need to do collect to tell it, okay, I'm done with the stream. Please put this back into a list for me.
But if you put a for each, would that be this? Oh, would that be
Yeah, if you do a
stupid.
for each, you're done.
It'll also.
You
Yeah.
can't put in a variable because it doesn't even return anything. It just runs each.
Oh, you can't do for each. Yeah. That makes sense.
Yeah.
Okay.
Yeah, and in fact, if you do this, you still can't get a variable because if you do a for each, yeah, this thing, the for each doesn't return anything. Yeah, it's a void. Okay, let's see what. Yeah, and it printed out everything. So it printed out. That's funny that this rounding error. But yeah, it printed out the values, or it printed out all the lists with all the updated values. Okay, there was one more reduce, but I think we could cover that on Thursday because there's still sorting, there's min max, there's distinct. All yeah, these are helpful too.
Have you used streams at all in your code in your
Yeah.
work?
Oh yeah. Yeah, definitely. So it's not like
Wait, what about Big Mac? Big Mac, do you use them?
yeah, do you use them? I think you
No,
have. No,
not for my work.
but you
It's
know how to
for
use it though,
loops.
right?
You just go straight for
Yeah.
loops?
Yeah.
He does it in JavaScript, and JavaScript uses this stream,
Oh yeah, JavaScript. But not Java.
but not Java. Yeah.
So JavaScript has this type of
Yeah.
like method of looping?
Yeah.
Interesting.
Yeah. But the thing is, and what's hilarious is this is JavaScript, and the only thing keeping me from using it in Java was I didn't realize that the arrow is a single slash in Java. But it's the exact same operators too. So
Like the
it
names
is
too,
like
like peak and for
yeah,
each and all that
yeah,
shit.
yeah, yeah. So it's like a second language. It's a second language embedded inside of Java
Java. Yeah,
and JavaScript.
I got it.
So
Oh, that's
what are
kind
the
of cool.
words for this? So there's streams, functional programming, um, Lambda. If you hear any of those keywords, do not get afraid. You need to realize that they're just talking about this.
So what
So
do they ask? Like, what's a lambda? Would they just
yeah,
ask that
yeah,
or?
you could be like, oh, it's like an anonymous function. Uh, it's very helpful because you can use operators like for each or map or peek or collect to do different operations on your stream of data. Like, I mean, and they'll know exactly what you're talking about. You're like, oh, okay,
In
cool.
lambda, in this code, what's the lambda?
The
The
lambda
arrow
is
thing?
this right here, the arrow function. Arrow function, yeah, another arrow function. Lambda, anonymous function, arrow function, right? The lambda, arrow function, anonymous function is this, okay? You
And
use this,
it's the idea of like it's almost like to what you have in a for each loop where you get an
yeah,
element and you can mess with the element.
yeah, like
Anonymous
this right here.
function is why is it called anonymous function?
Because there's no name on it. There's no function name to it. Like this is a
Oh,
function
it's
name.
doing something. I see. It's doing something, but without an actual
Yeah,
call.
yeah. Well, you're invoking it, but this thing's invoking it because
Yeah.
it's invoking it by memory address, not by the name itself.
Yeah. Eesh. Okay, that's crazy terms.
Yeah, I
All
know.
right.
Very scary. They use it as gatekeeping all the time, but
Just to scare you out, but they
yeah.
shouldn't have.
Well, not to scare you out, but to like eliminate you.
Just, oh yeah, to make sure that you actually know what the hell.
Yeah. So this is the second part. There's method types and pipelines. So as we've been discussing, Java Stream operations are divided into intermediate and terminal operations. We were talking about that before. Intermediate means that you can chain the operations. Terminal means that once you put that operation in, you cannot continue it. It is done at that point. So intermediate operations such as filter return a new stream on which further processing can be done, and we've seen this in the code itself. So right here, like this is what is intermediate right here. So we're doing a dot peak, and then when you do a dot, you then still can do another peak, another filter, another collect, so on and so forth, okay? But an example of a terminal is this collect.collectors2list, where if I hit a dot, I have to reopen another stream. Actually, a better one would be a for each, because that one is definitely a terminal. So let's see here. For each, well, we can just do this one right here. So now when we do names flat stream, we can do names flat stream dot stream. So notice we have to create a new stream, right? That's why I said that this one was terminal, because you actually have to create a whole new stream here. And then you can do a for each, but as soon as we do a for each, right, and you hit dot after the for each, you don't have any more accessibility. So that's what terminal is. Okay, so here it is right here. A stream pipeline consists of a stream source followed by 0 or more intermediate operations and a terminal operation. And we just covered that. Here's a sample stream pipeline where employee list is the source, filter is the intermediate operation, and count is the terminal operation. So, oh cool, so they're using the count here. So long EMP count is equal to employee list dot stream. They start the stream. Here's the intermediate where they do the filtering, and then any employee that has a salary over 200,000, this terminal operator is just going to count it. So this is a really cool way to get counts of different items within your stream. And so here it would give us a long, apparently this thing will give you an answer of 1. Some operations are deemed short-circuiting operations. So, okay, so right here, so this right here is a stream where it's iterating through this function here, and it starts with 2, and it's going 2, 4, 8, 16, so on and so forth. But it is infinite because it doesn't end ever. All right. So what this short circuit operation does is it skips the first 3 elements of that stream, then it limits it to just 5, and then it collects them and puts them to a list. So that's pretty cool. So skip and limit are actually very helpful. I've actually used them in enterprise. So skip lets you skip ahead, and then limit lets you take X number of elements from there, and then you can collect them and put them inside of your logic. Okay, here we use short circuiting the operation skip to skip first 3 elements, and limit to 5 elements from the infinite stream generated using iterate. We'll talk more about infinite streams later on. And then finally, the cool thing is lazy evaluation. One of the most important characteristics of Java streams is they allow for significant optimizations through lazy evaluations. So computation on the source data is only performed when the terminal operation is initiated and source elements are consumed only as needed. All intermediate operations are lazy, so they're not executed until a result of a processing is actually needed. So for example, consider the find first example we saw earlier. This is a terminal. It ends the stream. It returns an optional, right? A bucket. How many times is the map operation performed here? 4 times, since the input array contains 4 elements. So right here it says when find first, then get first employee in stream. So we have an array of employee IDs. Then we stream through the employee IDs. We then map employee repository find by. So we find the employee from the repository. We're converting it from a integer into an employee right here. Then we're filtering. We're keeping all the employees that are not equal to null, which means does the employee actually exist? And then if the employee exists, we then filter out we filter in. We keep everybody who has a salary over 100,000. Okay, and then we send find first or else null. So what we're doing here is we're running through all of these criteria, and then the first one we find, that's going to be the optional. But what's cool is Java is smart enough to know that since you're doing a find first, you don't have to loop through every single one of these. Okay, so if it goes through the first one and it doesn't exist, right, then it's going to hit this part and it's going to get filtered out. If 2 exists, then this will be true and it'll keep it in there. We'll check to see if employee number 2 has a salary greater than 100,000. If not, then he's out and then there's nothing there. Find first is going to say, oh, there's nothing there. Then when you do the third element, let's say we find the employee exists, the employee salary is 200,000, right? So we'll keep them, and then we get to find first. Find first then says, oh, I have an actual employee. I'm going to now return this. Okay. So you don't even, at that point, you don't even have to run item number 4. So this is very, very important to understand, because if you're expecting the logic to execute for all of this, it's not, and you might end up with the bug that you don't understand why it's not working the way it is. So remember, this thing is optimized. It will only run what it has to get your answer. Okay. Stream performs the map in 2 filter operations, 1 element at a time. It first performs all the operations on ID 1. Since the salary of ID 1 is not greater than 100,000, the processing moves on to the next element. ID 2 satisfies both of the filter predicates, and hence the stream evaluates the terminal operation find first and returns the result. No operations are performed on ID 3 and 4. I changed the example a little bit, but it's the same thing here. No operations are performed on ID 3 and 4. Processing streams lazily allows avoiding examining all the data when that's not necessary. This behavior becomes even more important when the input stream is infinite and not just very large. Okay. Comparison-based stream operations. So this is a very popular one. You're gonna see this a lot. So let's start with the sorted operation. This sorts the stream elements based on the comparator paths we pass into it. So for example, we can sort employees based on their names. So to do that, you do list employees is equal to emp list.stream. So we start the stream, and then we do dot sorted. Okay, so dot sorted is an intermediate one. It could be a little confusing because there could be a dot sort. There's other ways of sorting an array, but remember, these do not affect the original array. So this is great. So when you do emp list.stream.sorted, you are not changing the order of the emp list. You're keeping it the way it is. So we're going to do emp list stream, then we're going to do dot sorted, and here you need to pass in a comparator. Now the way a comparator works is you pass in two values, E1 and E2, and then here and Java, all the objects in Java have a dot. Most things have a dot compared to. You can either use a dot compared to or a dot. You can do a dot compared to. Okay, and the way a dot compared to works is it returns either a -1, a 0, or a 1. And so if E1 dot get name dot compared to E2 dot get name, this is saying if E1 get name is less than E2 get name, return -1. If E1.getName is equivalent to E2.getName, return a 0. And if E1.getName.compared to E2.getName is greater than 1, if E1 comes after E2, so this is like alphabetical order, right? So if this name starts with a B and this is an A, then you want to return a 1. Okay, so with that logic of -1, 0, and 1, you will then be able to sort everybody. You'll be able to sort however you want. Here's a nice trick. If you want to sort by backwards name, you put the E2 here and you put the E1 here. Okay, so if E2 is bigger, then it will return a 1, and if E2 is less than E1, it'll return a -1. But just remember that. So you do E1, E2 like this, and then if you want to reverse it, put E2 and then E1 like that, or you swap the E1 and E2 around. Once you've done the sorting, you can then collect them and put them into a list. And then from here, you can then do your asserts, and you can find out the different, the names were sorted properly. Bill Gates, Jeff Bezos, Mark Zuckerberg. Let's see here. Note that short circuiting will not be applied for sorted. This means in the example above, even if we had used find first after the sorting of all the elements is done before applying the find first. This happens because the operation cannot know what the first element is until the entire stream is sorted. Yeah, that makes sense. You can't short sort it. You can't optimize it because you got to sort it no matter what, right? So but this is a very useful operator. Min max, as the name suggests, min and max return the minimum and maximum elements in the stream respectively. Based on the comparator, they return an optional since the result may or may not exist due to, say, filtering. So you can have emp list.stream, we do a .min, and then here is the comparator that we use. So you don't, I'm assuming in Java there is like default comparators. So if you have like an integer, what the E1? Oh, look at this. So it's doing E1 get ID minus E2 get ID. So this is going to give you either a -1, a 0, or a positive number. A negative number, a 0, or a positive number. So instead of doing a comparator, they're doing like a little fancy math trick. And based on the -, 0, or positive number that gets returned, the min operator will figure out how to get the minimum value from there. Nah. Let's check it out. I want to see this real quick. Okay, so because it's gonna have to sort them. Yeah, it's gonna have to sort them. So let's do this real quick. So we're gonna do when find min, and we're going to get our what did we have? We had, I forget what we had. Array of imps. So it's this right here. Let's do employee list. Okay, and then we're going to do employee list. Oh, I'm in the wrong spot. We're going to do employee list right here like this, and we will do employee list.stream. And then let's get the guys with the minimum salary. So E1.getSalary, right? You can do a compare to. e2.getSalary, and this will give you the minimum value. So now when we do this, let's run it. What is it? Why is it saying there's something wrong here? Let's see what the error is. Oh, it's saying that you can't use new integer. Okay. No, the answer is not going to be 1. The answer is going to be 100,000, I think. All right, let's try this again. Nope, still running. Let's see what the error is here. It doesn't seem like there's an error there. Okay. Okay, so it expected 1, actual was 1. Expected Java long 1, but was Java integer 1. Are you serious? Oh, we don't want get ID. We want get salary. There you go. That's interesting that they made it unequal based on the data type. Okay, let's see what we got here. There you go. It worked. So if we change this to 200,000, oh, it should actually be swapped around. My bad. Then this will not pass, and we should get. Yep. It expected 100,000, but the actual was 200,000. So if I change, it should be 100,000. Now, if you, let's see what happens if we do E2. I'm sorry if this is confusing, but I'm curious. Let's see what happens if we reduce our comparator. So our comparator is now broken because bigger is now smaller. So let's see what happens. It's probably going to return 300,000 because we screwed it up. We confused it. Yep. See, actual was 300,000. Okay, so right here, remember, if you want ascending order, the E1 and E2, so the left and the right here, have to match the order here. E1, E2, and then you use a compare to, like that. All right? So if E1 is smaller than E2, it should be a negative. So this is how you usually do it right here with the comparator. So this whole thing is basically an anonymous comparator. That's what they call it, okay? It's it's an anonymous function, it's a Lambda function, but when you create a comparator class, there's a certain method that you need to implement. So, long story short, you can just you can call this a comparator. See right here, the method that you have to implement is comparator.comparing, right? But it's just an anonymous function. Okay, so let's try something else. We're going to try what they have. We're going to try E2.getSalary minus E1.getSalary. And if E1, why is this not liking this? Double cannot be converted to it. Oh, it's a double. Oh, that's right. Okay. So let's just do an int like this. E2 minus E1 like this. So if E1 greater, so if E1 is smaller than E2, let's just run it. I'm not even going to try to figure it out. Let's see the right, so the order does matter because remember, the smaller one should return, yeah, so I had it wrong. So, you got to follow the order. So E1 minus E2 like this should be the same thing as E1 dot compared to E2, okay? This is like a fancy way of doing it. I would rather you use the compare to because it's telling people that you're making a comparator. And see, it passes here too. So even though the logic is -1, 0, 1, it still works with any number that's negative, a 0, and any number that's positive. It still treats them the same way, okay? And what this bin is doing is it's actually sorting everything under the hood, and then it's coming up with what is the smallest value. That's why the number sometimes comes out as 300,000 because you're sorting it in reverse order, and then it says, oh, I got the first element of that sort. This is the value, okay? So kind of confusing. The only way to get around it and make sure that you're always legit and you're always good. If you're doing a min or a max, make sure that your comparator has E1, E2, and that your E1 and E2 is following the same order. And if you can do that, you are good to go. But I'm also going to use compare to. So get salary dot compare to E2 dot get salary, and we should be good to go there. Finally, IntelliJ lets you refactor this. You can replace this with comparator comparing. So you can replace it with this, and it's going to basically say comparator comparing employee gets salary. So what this is saying is you're using the default Java comparator, and you're going to compare it based on the get salary method in ascending order. So this is kind of nice because you don't have to worry about stuff not making sense to you. But for the sake of you understanding what the comparator is, I'm just going to leave this code here like that. All right. Okay. We can also avoid defining the comparison logic by using comparator.comparing. Oh, they just covered that. And they do comparator.comparing employee. I mean, they just did this. Cool. And then finally, or else throw no such element exception use. So this is really nice. If there is no min, you can then do an or else throw. Oh, they already have it here, right here. And you can put no such element exception here. Okay. So let's say if we filter out, so when does that happen? This happens if we do a filter and we're looking for salaries over $1 million, right? Nobody's making over $1 million. So because of that, you're not going to end up with anything. So you're going to throw an exception. When we run this, you should throw a no such element exception. Yep, and there it is. No such element exception. Very cool, very cool, very cool. All right, let's keep on going. Distinct. Distinct does not take any argument and returns the distinct elements in the stream, eliminating duplicates. It uses the equals method of the elements to determine whether two elements are equals or not. So basically, if you have a raises list 2, 5, 3, 2, 4, 3, then it's going to return 2, 5, 3, and 4. So it'll get rid of the 2 because it's a dupe of this 2. It'll get rid of a 3 because it's a dupe of that 3. So that's pretty straightforward. If you have objects, so this is cool if you have a list of items and you don't have a set, but you have to deal with it in a list, right? So like if you have a list of items and you want to get out the duplicate, remove the duplicates, you can just do stream.distinct, okay? And if the objects are the same, it will get rid of them. So if they have the same reference, it'll get rid of them. It might not work if you have the same values in the objects, but different memory addresses. The only way that will work is if you use Lombok or if you create a new toEquals method, because that's what it says here. It uses the equals method. Sorry, the equals method. If you overwrite the equals method and use value-based comparison, okay, so I can show you real quick. If you use value-based comparison, so I'm going to go refactor, generate. By the way, at data, if you're using Lombok, at data automatically does this for you, okay? But if you're not using Lombok, you can generate equals and hash code, and you pick all the fields. And so what that does is this will compare two objects together, two-person DTOs, and if the person DTO that you're comparing with has the same first name, same middle name, same last name, same birthday, and same phone number, Java will treat them the same. Okay, so even though they might be living in different memory addresses, right? If you create this code, then it will check to see if they match based on the values, which is kind of cool. Very easy for test. It makes it a lot easier to test these things. Okay. But data already does this. At data already does this, so we don't need to do this. So I'm just going to delete this. Okay. If you have any questions, please reach out to me. I can try to explain that a little bit more. Okay. And then finally, I think we're good here. I think we're going to be done here. Oh, we still got the reduce. Ah, shoot, we got joining to set. Maybe we could do this next week, but what we have here is all match, any match, and none match. These are very, very cool. These operations all take a predicate and return a Boolean. Short circuiting is applied, so it doesn't do it over everything, and processing is stopped as soon as the answer is determined. So these are very cool because what you do is you look at all match basically returns true if every element matches your criteria. Okay. Any match returns true if one of them matches your criteria. And none match returns true if all the elements do not match your criteria. Okay, so this is very cool. If you're instead of you have to go. Let's say you're going through a list of elements and you want to find all the employees with the salary of 100,000. You want to know if there actually is an employee with 100,000. So what you would do is you would do int list.stream. If you're looking for any employee, you can do any match e, and then e.get salary is equal to 100,000. So that will return true if one of the employees has a salary of 100,000. Okay. Let's say you're looking to see that all the salaries are over 0, right? So if you do employee list.stream all match and you put the e here and then e.get salary greater than 0, then this will return true because every employee will have a salary over 100,000 or over 0. But if you change it to a million, or let's say 100,000, greater than 100, let's say 150,000, right? There's one employee who only has 100. This thing will return false. Okay. And the same thing with non-match. Non-match will return true if none of your employees meet the criteria. So what they're doing here with this example is they have a list, right? 2, 4, 5, 6, 8. All even. So they check all match. Are all of these even? So they say if so the element I mod 2 is equal to 0. So they're basically saying is 2 mod 2 equal to 0? Yes. Is 4 mod 2 equal to 0? Yes. Is 5 mod 2 equal to 0? No, it's a 1. So this automatically returns false. It doesn't even process 6 or 8. It just automatically says, nope, this is false, and all even is now false. Here we have Boolean 1 even. So int list.stream any match. So this is saying if any of these are even, we're good. So the first one is a 2. So 2 mod 2 equals 0. So that's a 0, right? So then this automatically is true. So Boolean 1 even is now equal to true. It does not even execute the rest of this stuff. Okay. And then finally we have int list stream dot non match. So this is looking for that there is no number that is a multiple of 3. Okay, so 2 mod 3 equal to 0. Nope, that's false. So non-match. So yep, number 2 doesn't match that. We're good. We go on to 4. 4 mod 3 is equal to 1. Nope, 1 is not equal to 0. So this does not match. So we're good. We go on to the next one. 5. 5 mod 3 is equal to 2. That's not equal to 0. We're good. Non-matches. We'll go to the next one. Then we have a 6. 6 mod 3 is equal to 0. So 6 divided by 3 is 2, remainder 0. So because it's a remainder of 0, this is a match. So this now is false. Oh, one of these matches, so that means non-match is not possible. So we're going to put false here. Okay, and then this stops running. It doesn't execute this. And then you can see here that the asserts all even false, asserts 1 even true, asserts non-multiple 3 false. So I'll just copy and paste this test so that you guys can have it in the code itself. Okay, and then we can run it and you'll see it in action. Yep, there it is. It passed. Okay. Stream is a stream of object references. However, there are also int stream, long stream, and double stream, which are primitive specializations for int, long, and double. These are quite convenient when dealing with a lot of numerical primitives. These specialized streams do not extend stream, but extend base stream on top of which stream is also built. Okay. As a consequence, not all operations supported by stream are present in these stream implementations. For example, the standard min and max take a comparator, whereas the specialized streams do not. Oh, that's interesting. So because we're using an int stream, you don't need to define what min or max is. And if you remember, we used the comparator with min and max before, and we found that if we took the comparator and swapped the compare logic, you can actually get non-intuitive type of results. But if you're using an int stream, long stream, or double stream, it's following the order of how a number is supposed to be. So that's cool. The most common way of creating an int stream is to call map to int on an existing stream. So let's take this test and we can run it. So when we're going to take our employee, so it's our employee list. So we need to get our employee list here. So let's put that here, and then we're going to put our employee list there. Okay, so we're going to stream through all these. We're going to do map, and then for each employee, we're going to call this method. Oh, it's going to, the reason it's actually map to long. So let's do a map to long. Map to long. Okay, and then this is going to be the get, because remember the IDs are longs. So we're going to do a get ID. So now this works. And this is going to be a long now because it's the latest employee ID. So what we're doing is we're streaming through all the employees. We're mapping. So remember, map is you provide, you execute a function on each element and you convert it to a different data type. Okay, so they're using the word map in that sense here. And what they're specifying is that you're also mapping it to a long, basically. So we're converting an employee, we're converting each employee into a long number. And then once we get the long here, we then call .max, and .max will give us what is the maximum number. And if there is no such element, then it'll throw this no such element exception. That only happens if this is an empty list, basically. Okay, and so now that we've done this, we're gonna take this off, and this should actually be, why did we put it in here? It should be here. So the 3, the latest employee ID should be equal to 3. And let's go ahead and run this. That's pretty cool. I was not familiar with the whole int stream, double stream, long double stream. I mean, I've seen them before, but not to the extent of, oh yeah, we can use these as a tool type of thing. Okay. Let's make sure this, yep, this thing passes, so we're good. If we change this to a 4, it should say fail because it's supposed to be a 3. It's not letting me run this test. I don't know why. Yep, still going. Oh, it didn't even run. Oh yeah, there we go. Wait, what? Let's run this again. I think it was still loading up number 3. Yeah, it failed. Yeah, so it's actually 3. It has to be 3. So let's change that back to a 3, and we're good. Okay. Now, what's cool about the whole int stream that we see here, it says here we start with stream employee and get an int stream by supplying the employee get ID to map to int, which in our case is map to long. Finally, we call max, which returns the highest number. Yep. We can also use int stream of for creating the int stream. So we can do int stream of 1, 2, 3, or we can do int stream range, which is int stream.range 10 to 20, which creates an int stream of numbers 10 to 19. Cool. So let's see if we can do that. So in here, I'm going to create another one. Int stream dot range, and we're going to go 10 to 20. So it looks like, oops, it looks like the 20 is exclusive. So we're going to do this. Why isn't it letting me do int stream? Okay, I should be able to import this. There you go. There you go. Okay. So when I do a range here, then what I'm going to do is I am going to do a for each. Let's do a peak because a peak will let us access an action on every element. So we're going to put an E here, and then we're going to do an S out, and then it's going to be number colon, and then we're going to put the E number there. And then because remember what peak does, peak is intermediate. It allows you to keep on going with the stream if you wanted to. And so if we wanted to, we can do a dot max here. And I think we're good there. So we're going to do a integer max is equal to this. I think I have to do a find first. Optional int. Okay, let's do a dot get. Get is in. Wait, what? Dot. There's an or else throw. They're going to make us do that. Okay, so we're going to do an or else throw. We're going to do a no such element exception new. So we're calling the constructor. We're going to just throw our own no such element exception. But if you wanted to, we could probably do this too. We can do new no such object, no such element exception. But we can actually pass in a string here. This list cannot be empty. Let's see if that works. Oh, I think we have to return it. There you go. Let's see where we at. What happened here? Okay, so I guess we can't do that. We have to do the anonymous function. So we can do E, and then we're going to do throw. Why are you not liking this? I guess we're going to have to do there has to be a way of doing this. Let's just do new. Let's just do the new the way they have it now. We might want to explore that later. Okay, so that works, right? So if we run this, we should get that max should be equal to 19. And they printed it out, 10, 11, 12, all the way up to 19. Cool. So this is an example of a range. Let's do range. Show example with int string. Okay, and there's the code, and then when we run it again, it should work. Okay. And then let's see here, specialized operations. Specialized streams provide additional operations as compared to the standard stream, which are quite convenient when dealing with numbers. So we have sum, average, and range, right? Those are just a few of them. So we can actually, we can do an average. So average only works on numerical streams, basically, is what they're saying. Is you can't go in and well, the whole average thing, usually if you're using a bunch of objects, the average has to be adjusted for a specific field, right? So what we're doing here is we're going through an employee list, right? And then we map it to a double. So what comes out of here is now a double stream. Okay, and because now it's a double stream, it's numerical, you can now have access to these special operators, which is the average. So we're going to do dot average or else throw no such element exception. And then what we're going to do is we're going to assert that the average salary is 200,000, and it should be 200,000 because it's 100,000, 200,000, and 300,000. So the average should be 200,000. All right, so let's go ahead and run this. Awesome, it works. So according to this, you have sum, average, and range. So if we wanted to, we can do a sum here. This will now fail. Oh, look, it doesn't even require a throw else. Okay, cool. So now if I run this, this should fail because it should expect 600,000. Because 100,000 plus 200,000 plus 300,000 is 600. Yep, see right there? it actually got 600, not 200. So this, when we change it to the sum, it'll try to sum up every value from your double stream. So let's go ahead and get rid of that. When apply sum on int stream, then get sum. So yeah, that's a typo for that's a typo in the lesson. But what we can do is we'll do this. We'll add another one. So we're going to take this out and we're going to do double sum is equal to employee less dot stream. We're going to map it to double, but this time we're going to do the sum, right? And we don't need that, or else throw, because remember, if the list is empty, the sum's going to be 0. So that's why you don't need to throw an exception. All right, and then we're going to then make another assert, and here it's supposed to be equal to 600,000, and we're going to make it equal to the sum. So now when we run this, this should now pass and work. Okay. Okay, so that passes, great. And now let's keep on going to the rest. So in here it says a reduction operation, also called as fold. Okay, I did not know that. A reduction operation takes a sequence of input elements and combines them into a single summary result by repeated application of a combining operation. We already saw a few reduction operations like find, first, min, and max. Let's see the general purpose reduce operation in action. Okay, so this sounds complicated. It's way more complicated than what it really is. A sum or an average is taking a group of elements and ending up with one value. That's all a reduce operation does. It's taking a group of elements and doing something to them or processing them in such a way so you end up with one value. Okay. And so the most common form of reduce is T reduce, T identity, binary operator T accumulator, where identity is the starting value. So they're saying that this is the starting value, and accumulator is the binary operation we repeat apply. So, okay, let's take a look if we can break this down. So in here, we're going to get back our employee list. Okay, and this is going to be employee list. All right. So we stream through each of these employees. Remember, when we do a map here, we are then getting the salary. So if you really wanted to, you can do a map to double, right? Employee gets salary, and then this would automatically be treated as a double stream, okay? But you don't have to do that either. I mean, we can just do a regular generic map. You're still going to get up with the stream of type double, but it's not the same thing. Like we just read before, a stream is a generic, or a stream can use any data type, but it doesn't have the same functionality as the numerical streams, okay? So for whatever reason, in this case, we chose to use the generic stream that is using double, all right? And I guess they're doing that because instead of doing a sum, because what they can do is, we just talked about it, they can just do map to double, and then they can just sum it, which is so much easier, right? Like that. Like that. Where they're choosing to show you how the reduce actually works. And not everything is going to be like a sum or an average. You might have way more complicated logic that will reduce your data into one value. Okay, so like maybe it could be something like, give me the third max value of the day, or give me, get all the numbers that are bunched up together very closely, and then get me, or a better example would be, give me the value that is the most common occurrence, which is the mode. So if you could, like, that could be something else. There is no mode option. So you need to be able to define that behavior. And so this is what the reduce allows you to do. Okay. So employee list.stream, we're going to do dot map, employee gets salary. Now what we're doing is we now have a stream, and then we're going to reduce it. So our initial value is going to be 0.0. That's the identity. Okay. And then the double sum is going to be the method that we are running. So double sum is actually a thing? That's crazy. Yeah, double sum is actually a thing. You take a double and then you add two elements. That's weird. You could also do this. You can do E1 comma E2, and then you can do E1 plus E2. Okay, so what this is doing is it's taking the first value and the second value and then returning it. So let's see if that actually works. It should be 600,000. I would actually prefer this way. I mean, no, the other way looks cleaner, but for the lesson that we're trying to teach, like you need to know that you can put an anonymous function in here. Okay, and then you put in the E1 and the E2. So E1 is going to be, I think E1 is the sum. So let's go back and look at that here. So the binary operator is the accumulator, where identity is the starting value, and accumulator is the binary operation we repeat apply. So how are we going to do this? So actually we can do this. So I'm going to put a curly brace now so that we can have, so this means that you have multiple lines. Okay, and now because we have multiple lines, we need a return now. Okay, and then here I'm just going to S out E1. And then we're going to S out E2. All right, and then we're going to see how this thing operates. So let's go ahead and run this. So remember, the initial value is 0. And then E1 and E2 are binary operators. So that means it needs two values. All that means is it's an operation on two values. That's all binary operator is. Okay. So E1 at the beginning is 0. E2 is 100,000. Okay, so this is how it works. So E1 is the accumulated value. Let me rename this again so that we actually get a very good understanding of it. So this is the, rename code occurrences, yeah. So this is going to be accumulated value, all right? And then this one is going to be the element itself. So this is the element, okay? So what it's doing is it's going through each one of these, right? The accumulated value is the final result of this, okay? Okay, this is the updated accumulated value. And let's change this to that. Here's the element. Okay, so what does this mean? Let's go ahead and rerun this and I'll show you what it means. So you start out with an initial value of 0, right? So you start out with a 0. So then when you execute this on the first two elements, you execute this on the first element, the accumulated value is set to the 0. So that's what you see here. And then this element, which is the first element, gets processed. So we're going to print out what is the accumulated value now, what is the element now. We see that 0 and 100,000. And then what we do is we're saying accumulated value. So let's do this. Accumulated value is equal to accumulated value plus element. All right, so that's what this is basically saying. This is the equivalent statement for statement. This is the equivalent for statement below. So what's happening is the accumulated value plus the elements are added together and then they are returned. And this accumulated value gets updated. And we can tell that because in the next iteration, so for the second element, so it goes through the first element, then it goes to the second one. You don't need this anymore because this is only the initial value. Okay, so this doesn't matter anymore. The only thing that matters is what is accumulated value and what is element. So for the second element, the accumulated value is now 100,000 and the second element is 200,000. So then you go through, you print them out, which is right here. And then you then say accumulated value is going to be updated to be equal to accumulated value plus the element. And so now that you've done that, you take 200,000 plus 100,000 and you get 300,000. So this thing completes and then it runs again. It's running on the third element. The third element is 300,000. Also, the cumulative value is 300,000 because 100,000 plus 200,000 is equal to 300,000. And so as it goes through again, it says accumulated value plus element. So 300,000 plus 300,000 is now 600,000. And after the whole, because now we're done with the entire stream, it then returns this value into some sal, which is 600,000. And we get that because we can do an assert here. And I got to fix his as assert here. So it's going to be 600,000 and some sal like that. So when you run this, this should be 600,000. Okay, you can do a bunch of other cool stuff with this as well. It passed, good. You can do a bunch of other cool stuff with this as well. So we can do something like this, right? Like what can we do? What are we going to use in an accumulator? Let's use average raise, I guess. Can we do an average raise or amount? Let's do that. Amount or raise budget. So let's do raise budget. Okay. And so what we're going to do is we're going to give everybody a 10% raise. And then we want to figure out how much it'll cost to give everybody a 10% raise. Okay. So here is our accumulated value. And here is our element. And so what we want to do is we're going to keep this the same. We'll print this out. But instead of doing accumulated value plus element, what we'll do is we'll do accumulated value plus element times 0.1. So let's say everybody's getting a 10%, 5% raise. Everybody's getting a 5% raise. Then we're adding it to the accumulated value. Okay. And so when we run this, we're going to get a total of how much it'll actually cost in dollars to give everybody a 5% raise. So in actuality, it should be 600,000 times 0.05, which, man, I used to be able to do that at the top of my head. Now I can't. Oh my gosh. So that's $30,000. Okay. So 30,000. And then we should be good to go. So let's go ahead and run this. Well, we didn't print it out, so let's do something here. Assert equals 30,000, comma, raise budget. There we go. So let's go ahead and run this. It should be 30,000. So I wanted to do this example. Yep, right here. So you see the first accumulated value is 0. Then you have the 100,000. That's the $100,000 going in. But the accumulated value, we're just not doing the simple example of a sum, okay? We're trying to do a little bit more complex math here. What we have to do is we get the amount that is the raise, which is element times 0.05, which is 5,000. And then 0 plus 5,000 is equal to 5,000. And then we go back around, and you can see that the accumulated value is now 5,000. And that the second element is 200,000. And so it goes through the calculation again. 200,000 times 0.05, so that's 20,000, 10,000. So 10,000 plus the accumulated value of 5,000 is now 15,000. Then it goes back around through, and so now you have 15,000 with an element of 300,000. And so 300,000 times 5%, that's 15,000. So 15,000 plus 15,000 should give you 30,000, and that is what we end up at the end. All right. Let's do this. So I think we were good on that point. Let's keep on going. Okay. So yeah, we're good on that. All right. So we already saw how we use collectors to list to get the list out of the stream. Let's now see a few more ways to collect elements from the stream. Oh, this is going to be the crazy one. Joining. Okay. So when collect by joining, then get join string. So what we're going to do is we're going to join. Oh, well, let's see what this does. Joining will insert the delimiter between the two string elements of the stream. It internally uses a Java util string joiner to perform the joining operation. Oh, joining is easy then. Okay, so I was thinking multi-stream, which we're probably going to get to here in a little bit. But let's go on here. So let's show how we're going to do that real quick. By the way, by now, if you are watching this and you're just overwhelmed by it, don't worry. You're not going to use all of these, but what's great about this is that once you go through it once and you understand what is possible with streams, you'll get a better appreciation of it, and you'll be able to talk about it at the very least about the functionality that is possible, right? Like this is all going to be very helpful. Okay, so employee list here, we're going to stream through it. We're going to map by employee get name. So we're getting all the employee names. Then we're going to join all the employee names with the comma space. You can do the same thing with string.join. So there's nothing really special with this, right? You can do string.join here, and you can put a comma like that. And then inside you can put array of, so look, I don't need a stream. Wait up, why is it not liking that? String.join, can we do employee list? Okay, I guess I proved myself wrong here. What the heck? So string.join, character sequence. Oh, this is why, okay, I like it. So if you had a list of strings here, right? And they were called names, then you could totally put names in here. Easy. So if you already have, it's not been initialized. Okay, cool. So let's do a new array list. There you go. So if you have a string of names, you can use string.join very easily. One line of code, done, right? But here's the problem. We don't have a string of names. We don't have a list of strings of names. We have a list of employees, which are objects. And you can't put objects in string.join because it doesn't know how to treat each employee. Okay? So this is where it becomes very helpful with streams. So even though string join, and you just saw my own realization with this, string join is very straightforward and easy. It's a one-liner. However, the requirement is that you got to have your list already be as a list of strings. Okay, but what they're doing here is they're using streams to then map the employee to a string. So they want to get it to this format, okay? And a stream is just so convenient. Otherwise, you would have to do, for employee, in employee list, right? Then you would have to do names.add employee.get name, like that, okay? So you would have to do all of this first before you can even run your join. Okay, so that's the old way of doing it, the non-stream way of doing it. Okay, and the stream way of doing it is actually a little bit more readable, and it's just nice. So you're gonna loop through every one. You're gonna map every employee to his name, which is exactly what we're doing here, right? And then once we do that, we're going to collect all of these, and we're going to use collectors.joining, which should return a string. Nope, he returns a collector. Returns a collector that concatenates. Joining does that? Returns a collector. Okay. What? Why does it say it's a collector when it's supposed to be a string? Let's see what happens here. Yeah. Wow. I don't know why they say it returns a. They should just say it returns a string. Well, let's see if this works. So what's happening is it collects all of the elements, and while collecting them, it concatenates them with comma space in between, and you can see that this actually passes. If I change this to, I take that Z off and I run it, you're going to see what the actual result is, and it's going to show that it doesn't match. So that's pretty cool. See right there? The actual came back. Oh, we need to always change this. Our boy doesn't like to put the expects at the beginning of a test. All right, so we're expecting it to look like this. However, we have a mistake in our test because we took out the Z by accident. When we run this, you're going to see that the real value is going to have Mark Zuckerberg. I'm showing this as an example to show that the test will fail without having that value. Okay, we're good here. So we're good. Okay, so that's nice. Let's go back to the other one. So toSet, we can also use toSet to set out a stream of elements. I mean, this is pretty straightforward. We actually covered this before. That's easy. You're just converting it to a set instead of a list. We can use collectors to collection to extract the elements of any other collection by passing the supplier collection. So collector to collection. Yeah, I mean, this is pretty much straightforward as well. Vector. Vector is a special type of collection. Yeah, vector is a special type of collection. I don't know much about it. Let's see what it is equal to new vector. Vector dot add. Oh, it's just a collection. A vector is a special collection. I don't know what it actually is, but yeah. All right, and then we have. So I guess what it's saying is you can create a vector constructor inside of the collectors.to collection, so that you can get a whatever you want basically from it. And so in theory, what you can do also is you can then take this and create a set out of it. You can create you don't have to do the toList portion of it. You can just get whatever you want. So you can do like a array list like this, right? And this should still work if you make this a list, right? Yeah. See, so when you do the to collection, it's basically any data type that inherits from collection. Okay, so array list, linked list, stack, queue, like there's all sorts of data structures. You just got to put in the right constructor here and then tell it what kind of, you got to declare the variable to be able to accept the appropriate data type. Okay, let's go ahead and run, let me fix this. All right, let's go ahead and run this. It should pass. Okay, and it passed. Good. Okay, and then summarizing double. Summarizing double is another interesting collector, which applies a double producing mapping function to each element and returns a special class containing statistical information for the resulting values. Oh, shoot. Let's go. All right. I like this. So instead of having to do all the streams or use all the operators, this thing does it all for you. So let's do this. I like this. I'm just going to put this as an example here. So copy this, paste. Okay. So what we're doing here is we're getting a list of all the employees. And then we're collecting them all. But what we're doing is we're collecting all of the summarizing double employee get salary. So this is like combining a mapper and combining a an aggregator. So when you say count, sum, min, max, average, those are like the aggregator operators. So it's combining a mapper, which is mapping our employee into a double, and then it is using the aggregator to get all sorts of information. So collectors dot summarizing double employee get salary, and then when we're done with that, we actually can get the sum, we can get the min, we get the max, and we get the average, and it's all stored inside of this double summary statistics object. That's nice. What else does it have? Stats dot get min, get max, get sum, combine. Oh shoot, you can combine it with other stuff too. Wow, that's crazy. Get average, get the count. Yeah, we can get the count. I don't know what and then is. That's interesting. All right, that's cool. So you can take your stat. That's nice. I might use this. I don't know if I can't think of a use case for it yet, but that's good to have this tool under your belt. Okay, so that's pretty cool. All right, let's keep on going. Notice how we can analyze the salary of each employee and get statistical information on that data, such as min, max, average. Yep. Summary statistics can be used to generate similar result when we're using one of the specialized streams. So you can use summary statistics as well. So if you map to a double, you can do dot summary statistics and it'll do the exact same thing. That's pretty cool. So you can do this on the numerical streams. This right here. Okay. Let's just throw it in there just so that you have it in the code. Okay, let's copy this. And then let's go ahead and run it real quick. So we're mapping it to a double, and then we're using dot summary statistics. There you go. Good. Okay, partitioning by. We can partition a stream into two. Oh, shoot. This one's crazy. Okay, we can partition a stream into two based on whether the elements satisfy certain criteria or not. Let's split our list of numerical data into evens and odds. Okay, let's go. This is going to get crazy. This is where it gets crazy, guys. Oh, shoot. This is where it gets crazy. I have yet to see partitioning out in the field. But if you can do it, that'd be pretty sweet. Okay, so we have 2, 4, 5, 6, 8 right here, right? So 4 of them should be even. 1 of them should be false. So what we're going to do is we're creating this is even. Oh, it's a map. So okay, it collects it. Oh, it does it by a map. It doesn't do it by a stream. Our heads are going to explode here in a little bit. Okay, so what's happening here, it's making a map. So we have the stream here. Okay, we have a stream and it's emitting 2, 4, 5, 6, 8, right? So we're going to process them. But then we have the collect, and what we're doing now is we're collecting it by partition it by this filter, by this predicate. So if the element is even, so let's change this to element. If the element is even, all right, which is element mod 2 equal 0. If the remainder is equal to 0, that means it's even. So that means partition it by this. So what's happening is the Boolean value. So if it's true, then the element gets stored inside of the true. Gets stored here as. How does it do that? How does it do it so? Wow, I don't understand how it does it, how it knows to do this. So like here's your map, right? Here's your Boolean, and then here's your list. I guess because it's a stream, it knows that it's going to be a list of items, right? So this is your key. Your key is your Boolean. So this method right here determines what your key is. Okay? So it doesn't have to be a predicate. It could be by name. It could be by anything, right? It could be like color, whatever. So what this is saying is if this is true, then store all of the elements that come up to true, put them all into a true, or put them in the map where the key is true, and then all the elements are in this list. And then if this thing ever becomes false, then put it inside of false here, and then add that element to the list for false. I hope I explained that right. But you can see right here, so let's rename this is even. So we're gonna do, we're gonna rename this to is even to or let's do Boolean to element map, just so that it's a little bit better understanding here. Bro, gotta put your expect this at the beginning. Okay. All right. So the Boolean to element. So what's happening is we have a Boolean to element map, and what we're saying is if it's true, the size is, or we're getting all the values inside of true, and what we're saying is true has its own list, false has its own list. When you grab true So when you grab true, so when we get this, right, and then we print out what's inside of numbers, you're going to see 2, 4, 6, 8. So let's run this. And what these asserts are doing is they're basically saying that the size of this first list is 4 because it's 2, 4, 6, 8, right? And then the size of the second list is 1 because there's one odd. All right, so let's do Boolean to element dot get false. Okay, but it doesn't, see the thing is it doesn't have to be true or false. So let's see if we can use this example with it. There you go. See? So you got 2, 4, 6, 8, and you got 5. And it's printing out both sides. So now if we go here, right, we're going to do an employee list. And then what we're going to do is we're going to do employee list.stream. But what we're doing here, let's do a map. And we're finding all the people that start with a letter, right? So we're going to do a string. And then we will do a list of employee. Okay. So what's happening here is we're basically saying employees grouped by first letter map. Okay. And let's see how we can get that done. So first thing, we're going to stream the employees, right? And then what we're going to do is we're going to then do the collect. And in here of the collect, we're going to then put in collectors dot partitioning by, okay, and then in here, this is where we have to add our element. Oh shoot, they do want a predicate. Why do they want a predicate? Crap, maybe I don't understand this. Let's see what we got here. Well, let's try it out. So the predicate, what is this one right here? By parentheses, they want this. What's this predicate? Downstream, collector, predicate. Okay, well, let's see if it's smart enough to do this. So we're going to do employee list. So we're going to do we have an element here, right? So we have an element, and inside employee. So for every employee, we're looking for employee that starts with, oh, why aren't we getting the employee here? Element's an integer. This should be an employee. This should be an employee. So we should get employee dot. Why don't we have any employee values here? Is there some, what the heck? Oh, what am I missing here? What am I missing here? Let's get rid of this. So collectors dot to map. Shoot, there's a value mapper here. Crap. Okay. Okay, I'm gonna have to either cut this out or you guys are gonna have to ignore me on this because I don't know how to do this one. Okay, so let's shoot. Why the heck is it true false? Maybe the next lesson will teach us. All right. So in this case, when it's true, it goes inside of the map. That's the thing I don't understand is how does it know to put it into the map? Is what the question is. Like, how does it know to put it into this map? That is my question because it's requiring a predicate here. What is going on? So let's see if the next test will tell us. All right, so let's go back to this. So here the stream is partitioned into a map with even and odd sort as true and false keys. Okay. Grouping by offers advanced partitioning where we can partition the stream into more than just two groups. Oh, okay, so by default, it automatically goes down to true and false. So partitioning by just breaks it apart. So what would happen here, and the reason it was breaking is because this list, or the map that we had, where are you map? Where are you map? Yeah, this right here has to be a Boolean. Okay, so once we have it as a Boolean, then this predicate should work. So basically what's happening here is E dot, now see, now it pops up. So E dot gets, we were confusing it before. So if E dot get name dot starts with A, like this, right? So let's do E dot get name dot to uppercase dot starts with A, then you will then put it in one list, and if it doesn't, you put it on the other list. So it's kind of like a filter, but a filter keeps the ones that you want. This doesn't get rid of the other one. This doesn't get rid of the negative cases. It puts them in a different spot for you so that you can process them later if you want. Okay, so let's see. I want to see how they did it here because I forget already. Partition by element. Oh, and they just close it. Okay, so now that we've done this, all right, now let's just print out what's inside of this, and you'll see that it's split out between two. It might be split out just with, there might be there might be nothing in true and everything in false, because we have Bill Gates, Mark Zuckerberg. Yeah, there's not, I don't think, there shouldn't be anything that starts with A. So the first list should be 0. So let's print it out what's in there. And for the false, yeah, look, for the false map, you have employee 1, which is Jeff Bezos, employee 2, which is Bill Gates, employee 3, which is Mark Zuckerberg, but the true has nobody in there because nobody starts with an A. But if we go back and we put in B for Bill Gates, we should then have Bill Gates in the true and everybody else in the false. Okay. Let's go ahead and run that real quick. Yep. And you can see that Bill Gates is in the true and the other two employees are in the false. So to use partition by, you need to have a Boolean key and a list of whatever your element is. Okay. So here it was Boolean list of integer because we are iterating through in integers. Here it has to be Boolean list of employees because we're going through a list of employees. Okay. All right. So that's that. I'm glad we got that cleared up. Grouping by offers advanced partitioning where we can partition the stream into more than just two groups. It takes a classification function as its parameter. So this is what I was talking about where you classify things by name or letter. This classification function is applied to each element of the stream. The value returned by the function is used as a key to the map that we get from the grouping by collector. This is great. This is what I was talking about. Oh, look, they're doing it right here. That's nice. Okay, so let's just copy this and let's put that down here. So, yeah, they're doing the example that I was thinking of, but it's great that they actually have it. So employee list, grouping by new character E dot, oh, they're just doing it by character. Okay. So, okay, what they're doing here. Oh, instead of partitioning, so partitioning means you have two groups and they're going to be true or false. Okay. What they have here is they're doing collectors dot grouping by, and then they're going to do grouping by E dot get name dot character at 0. Interesting. So they go through every character. So, okay, if you were going to do this, right? I guess this is an elegant way of doing this. But typically some people would think like, okay, if you're going to do this, then you would just do for character, or no, yeah, you can do character A like this, right? for character ch equals to a, ch less than or equal to z, right? ch plus plus. So we're going through each character, right? And then if each character, if one of the elements exists in this character, so you need a double loop here, right? So you got to do for employee. This is one way of doing it, but there's a more elegant way of doing this. So if you do it like this, right, and then you say if employee dot get name dot starts with, and then ch like this, right? Then why is it wrap using? Yeah, let's do that. So if employee dot get name starts with string dot value of ch, then what you're going to do is you're gonna have. There's a lot of complicated logic at this. You're gonna need a map. You're gonna need a. Jeez, do we even want to do this? Why not? Character, employee, and then first letter to employee map. So you go to new hash map like that. And then, oh, it's not an employee, it's a list of employees. Oh, shoot. List of employees like that, right? Okay. So if employee.getName starts with string.value of ch, then what we want to do is we get the list of employees under that name. So list of employees is equal to first, I'm going to use a trick here. First letter to employee map dot get or default. So I'm passing in the ch as the key. Okay. So if there is a list of employees for character A, I'm getting them. Otherwise, return a new empty list. So I'm going to do an array list like that. Okay. So employees is either going to get back the list that exists for key A, or I'm going to return a new list. Why aren't you liking this? Yeah, it's fine. So now that we have this, right? I'm then going to do employees.add the current employee, and then I'm going to save it. So I'm going to do first letter to employee map.put, and then I'm going to save it back in there. Like that. Okay. And then once I do, and then now you can just keep doing this over and over and over again. Look at all that logic there. It's I mean, it's not optimal. You might, there is a way to retweak this to make it better, but look at all the logic that has to be done to map out employees to a list under each specified letter. Okay. Whereas here you have group by alphabet. It's a map, character, list, employee. It's the same thing right here, right? And then we're going to stream through it. And then when we collect it, we group by e.e.getName.character at 0. Nice. So then you get this. That's great. So let's do this. Let's copy. Let's do both logics. First letter to map. Bro. Come on, dude. I don't know why I'm talking to him when he can't do anything about it, but this whole expected thing, come on. It has to go to the beginning. Got to take your test seriously. You're professionals. Okay, so now that we got that, and then we got to fix it over here too. All right. The next thing is we're going to fix the code to be equivalent to what it is for the stream. That way you can compare both of them. And I mean, it's a good interview question too. Like, how do you organize all the employees based on the first name of based on the first letter of their name? So this is actually a legit interview question. If you can do this quickly and easily, you're good to go. Okay, so let's look. So instead of having a dual loop, instead of having 2 for loops, right? If you can get away without doing 2 for loops, that is amazing. That's great. If you have to do 2 for loops, that's fine. You still get it done. But usually nested for loops are not optimal, okay? Because you have to process this. So you're processing this loop 26 times, but then you have to process it for every single employee on the list. So if there's 10 people on the list and you're processing this 260 times, so that could slow you down. Especially when you get to bigger numbers, that will slow down your app. Okay. So the way they do it here, though, is they go through each employee, right? So for every employee, they're going to then get the first character. So we're going to do character, first character is equal to employee.get name. We're going to do a 2 uppercase just to be on the safe side. And then we're going to get our char at 0. Okay, so we're getting the first character. Oops. We're getting the first character of the employee. Then we're going to now that we have that, we can now do this logic here. So first character is going to be the key. So we're going to see, do you have the list of employees? So let's do this. Saved employees. So these are the employees that are already saved in the map that are under this specific letter. So let's say it's Bill Gates, right? So if we get to Bill Gates, we're going to get his name, convert it, or get the first character, which is a B. B is now in first character. And then when we then look to get the list of employees that start with B, we call the map and we say first letter to employee map get B. However, when you start running this loop, you're going to end up with cases where there are no lists there. And so if there is no list there, you're going to get null. You can't add null, and you can't add, if this is null, this is going to crash. Okay, so let me show you. So we're going to do map.get first character like this. And then we're going to add the employee to the list. And then we're going to see, then we're going to save the list back to the map. Okay, so when we run this, this should crash. Yep, it crashes. And the reason it crashes is because it's saying there's a null pointer exception. So it says cannot invoke util list add object because saved employees is null. Wait up, what? Why is saved employees null? The reason it's null is because when you're going through this, right, the first time you hit an employee, it's going to be Bill Gates, right? So we get the first character for Bill Gates. So the first time, like right here, it is an empty map. There is nothing in this map, okay? It's an empty map, and that means that there are no letters, there's no keys, there are no values, okay? So when we go in here and we do character first character is equal to employee dot, or we're going to get the first character, right? Employee dot get name dot 2 uppercase. So that's a B. It goes in here. Then we go to the map and we say first letter to employee map, give me the list of employees under the key B. And it's going to return null because nothing exists because there's nothing in the map. So the reason I'm doing get or default is because get or default makes it so that if there is nothing there, if there is a null value, right, then it will return something. It's going to return a default value. And what I want to return is a new array list. So this is a very optimal way of writing your code. So what it's saying is if you ever come across the map and you ever come across a key that doesn't exist in the map, just return an empty list. And so we're going to return the empty list now to save employees. I'm going to add the Bill Gates employee to the saved employees, which is this line of code right here. And this is the most important thing, okay? I have to save this new list I just created back into the map, okay? So first letter to employee map, I then save at the B with the B key, saved employees. So now that I go through it, I'm going to keep adding more and more and more lists to it at different letters. And so that's what this is saying right here. So I get the first letter to employees map and I get B. So I get a list of employees, then I get the first employee, And I'm guaranteed, because I know there's only one Bill Gates in this list. There's only one Jeff Bezos in the J list, and there's only one Mark Zuckerberg in the M list. Okay, so I'm guaranteed I know that it's going to be the first element all the time because there's only one. That's why I can do get 0. So I do get B, get 0, and then I get the name, and it's equal to Bill Gates. So let me just show you one more time with the debug, and I think we can move on. But what's cool is all of this logic, all this craziness is one line of code. So Yoon would be proud. Let me show you real quick. So it would be one line of code like that. Yeah. So that's the power of streams. This one line of code replaces all these lines of code. So, okay, so now that we're there, let's step through it. So you can see here, the first letter to employee map has a size of 0. There is nothing in this, see, size 0. There's nothing in this map. We get the first character. The first character is a J. Oh, who's in there? Oh, it's Jeff Bezos? Yeah, it's Jeff Bezos. The first employee is Jeff Bezos. It's a J. We're going to go forward. We're going to then save we got a new save. So remember, there's nothing inside the employee map, right? So by default, we are returning a new array list. So now that we return a new array list, we put it inside of save the employees. Now, because it's not null, we can now add the employee. So now under saved employees, you can see here that there's nothing in there, right? There is an array list there, but it's size 0 because there's nothing in the list yet. But when we step forward in the command, we've now added our Jeff Bezos employee there, which is right here. Okay? And now that we've done that, notice how our map is empty still. Notice how our map doesn't have anything. We are going to be saving that list under the J key in our first letter to employee map. So I'm going to step forward once, and you're going to see here that on the first letter to employee map, there is now size 1. When I open this up, it's saying that the key is J and that the value is this list, array list. And when I open this up, you're going to see that it's Jeff Bezos there. Okay, so this map has the key of J and now has the list there, and we're going to keep on going through this. You're going to see the same thing here. This is now Bill Gates. The first character of Bill Gates is a B, which you can see right here. The saved employees is equal to get or default. So is there a B inside the map? No. The only thing in there is a J. So we're going to return an empty array list. So now that we've done this, you're going to see that saved employees has an empty array list. So saved employees, see how it has size 0? There's nothing in there. Okay. And now we're going to add our employee, which is Bill Gates. So we're going to add our employee. When I hit forward, you're going to see this thing update to size 1. All right. So now it updated to size 1. Saved employees now has Bill Gates in it. All right. But it's not part of the map yet. We got to save it to the map. But we're doing that right here. So we're saving it to the map under the B key. Okay, so look at the map here. There's a J key already from our last iteration. We're going to run it 1 through again, and you're going to see this entry get updated. There's going to be a J and then a B. We're going to hit forward, and there it is. So now you can see that this map has size 2, and it has a B entry and a J entry. And inside the B entry, you have the list of employees, one of them being Bill Gates, and under the J entry, you have a list of employees, one of them being Jeff Bezos. And then we go on and we continue on with the next one, and that's where you end up with the 3 different lists. So if you look at the first letter to employee map, you're going to see a B, J, and M entry, and each of these entries has their own list of employee, and you can see that each one has the appropriate value. So it has Bill Gates, Jeff Bezos, and then Mark Zuckerberg under the M. Yep, and so if we really wanted to, we can then do this too. We can do employee list dot add, and we're going to do a new employee, And inside this new employee, we're going to do a 4. And we're going to do Jerry Balderas. And then we can do a salary of 50,000 like that. Okay, and then let's see what don't you like about this? Is it supposed to be dot zero? Yeah, okay. So now that we've added a new employee here, right, and we go through this, you're going to see that there should be 2 J's. Now there's going to be 2. There's going to be a Jeff Bezos and there's going to be a Jerry Balderas under the J entry of the map. So let's go ahead and run that. And I'll put the breakpoint. Stop it, rerun. I'm going to put the breakpoint right here so that we can just go through the entire list. Okay, and so it got here, and you're going to see, let's see, go forward. Oh, yeah. See the employee list, how it has size of 4? What? What did we do wrong here? Employee list has a new employee. I go through each of this. Get or default equals saved employees. I add the employee, then I save it. Yeah. Let me rerun this again. Maybe you got confused because I didn't catch all my changes. Okay, so these tests are not going to fail. Let's try it one more time and see what happens when it runs right here. What are we? Oh, there it is. Oh, okay. This is where I was getting confused. So first letter to employee map has 3 entries, right? I thought it was supposed to have 4. It's not. It's supposed to have 3. It has a B, a J, and an M, right? That's why it's saying size 3. However, if you go inside the J, it has 2 entries now. When you go here, it's going to have Jeff Bezos and Jerry Balderas, both in the J entry. Okay. This is I'm going really deep on this because I think this is super important that you have to understand. You need to understand how maps work. You need to understand how because these are the type of questions you're going to get. Okay. So let's just walk through the for loop one more time and then we can continue. But like, for instance, here, if it's Jerry, right, when we get to the fourth, when we get to the 4th iteration of this, so let's actually redo this. So the first iteration is going to be Jeff Bezos, right? We're going to go through once. We're going to go through twice. We're going to go through 3 times. Shoot. I hit it too many times. Let's try it again. Okay. So we're going to go 1, 2, 3. So now we're on employee list. So when you look at first letter to employee map, we have 3 entries, right? So we went through it 3 times. So you have a B, you have a J entry, and you have an M entry, okay? So this is what happens when a list does exist. So I'm going to step over one more, and I'm going to see that the next employee is Jerry Balderas. That's the last one. That's me. The first character is now equal to J, okay? We're going to get the list that is under J. Well, the list under J actually does exist. It's right here, and it has Jeff Bezos under it. Right here, yep. So when we execute this statement, get or default, we don't need the default anymore. It ignores this because the list actually exists under the first character J. So when I run over this, you're going to see that saved employees has the Jeff Bezos record in it. Okay. And then now what I'm going to do is I'm going to add my record, Jerry Balderas, to saved employees. So when I go over once, you're now going to see that saved employees has 2 records, Jeff Bezos and Jerry Balderas. And then I'm going to save this back to the map just to make sure that it's stored in there. And when I run this, you're going to see that the first letter to employee map has 3 entries, B, J, M, but the J has 2 different employees in it. Okay? And what's cool is that's what this guy does. So if you wanted to, we can do the same thing here, and we're going to do Jerry Balderas. But this time we're going to get the J, and we're getting the second element. Okay, so we're going to do it like this. And we're going to copy this and put it here as well. And these should both pass. It's pretty crazy that all of this logic, all of this thought that has to go into making sure that the lists are populated properly, that they're instantiated, all of this stuff can be replaced with this line of code. That's the power of streams. Like, they don't even have to, you don't even have to worry about instantiating the list. It already knows how to set up the map for you. What? Crazy. So that's pretty cool. Okay. I think I beat that up a lot. Next one is mapping. So grouping by, discussed in the section above, groups elements of the stream with the use of a map. However, sometimes we might need to group data into a type other than the element type. Here's how we can do that. We can use mapping, which can actually adapt the collector to a different type using a mapping function. Okay. Oh, cool. So here we're going to get a list of integers. So instead of saving the entire object, you can save the entire, you can save like a list of IDs instead. Man, this is crazy. This is crazy, crazy, crazy. So let's copy this. Paste it here. Employee list right there. So what we're going to do is we want a character of a list of long because our IDs are long, remember? And then what we're going to be doing is we don't need a new character. We can just do e.getName character at. Yep. Okay. So what this is doing is we're going through each employee list. We're streaming through each employee. But then when we collect them, we then do a grouping by the first character. Oh, notice how there's a comma here. So this is all one line right here, like that. So we are getting the character, we're starting by the character, and then we're mapping employee.getID collectors to list. What the frick? What? Dude. Mapping. Get ID collectors to list. I'm sorry, I don't know what is going on here, guys. Let's figure it out. Let's figure this out. Gotta fix the test first. Okay. So, is group by. So if we go back up here, is group by. Or if we do grouping by right here, right? And we do grouping by here. We're then taking e.getName a character at 0. So this is the key. So this will return the key. So we're returning the key right here. And then what we want to do is we want to figure out the list. So collectors.mapping. Somehow this collectors to list basically tells us that this ID has to be added to a list. But the thing is, I don't understand why it's doing that. Shoot. Okay, but this should now run. So grouping by the first letter of the name, but instead of returning the employee, which you don't even include here as an option, it just assumes that you're returning the employee. Here you're going to be doing a collectors.mapping So you're mapping the employee to an ID, but you're also including this to list, which, yeah, this is hurting my head. Here mapping maps the stream element employee into just the employee ID, which is an integer, which is a long in our case, using the getID mapping function. These IDs are still group based on the initial character of the employee first name. We're going to have to explore this a little bit more in depth. I have yet to see mapping though in the field though. Reducing is similar to reduce, which we explored before. It simply returns a collector which performs a reduction of its input elements. Dot reducing. Oh, and it's the accumulator, and then here is the aggregator function. Oh, what? There's two of them. So there's the initial value, there's this, and then there's the accumulator right here. I'm going to include this anyways just so you guys can study it, but let's skip this. Yeah, let's skip this. And then finally, let's do parallel streams. This is the whole reason why I did this class. So the thing that Java 8 does is Java 8 allows you to do multi-threaded processing with just one keyword. So this is what made streams super powerful. Because now you can use different CPUs, like literally use different CPUs within the machine. So if you know anything about chips or computer chips or the chipsets, like they have multiple CPUs. You know, some might have like one, some might have two CPUs, four CPUs, 16 CPUs. Like they'll have additional CPUs. These are the processing. These are like the brains of your computer, right? You're not just using one, you actually have multiple. And it's like you have 16 different computers on your one machine. You just don't even realize it. And so with these multiple CPUs, you can make it so that you can use that hardware very easily within your application. Okay? And it is done using the parallel keyword. So let's go ahead and copy this. There's certain rules that have to be followed for parallel. Like they have to all be independent. If they're all independent, then it will work. If they're not independent, then the parallel will not work. Because you got to be able to run. Because what happens is it runs them simultaneously at the same time, and then it aggregates all the data back to you. So we're going to do parallel for each e.salary increment raise times 10, and we're going to it's this thing again. So we're going to assert that the raise was, let's see, we still have this code. Where's our 110 code? Man, we've done a lot of tests. There it is. So let's do this right here. Okay, so the main difference now is that we're doing this in parallel. Okay, so is there a way to show you that we're doing it in parallel? Okay, so this passes. So let's do this. We're going to add a bunch of people for int I equals 0. I is less than 1 million. I don't know if this is is it 1 million? Yeah, it's 1 million. We're going to do 1 million of these people, okay? And then we're going to do employee list dot add, and then we have to add the person's name. So we're going to do employee, and we're going to do I. So his name is going to actually, we'll start him at 1, and we'll go all the way to 1,000,000. So this person's name is actually going to be employee 1, employee 2, employee 3, so new employee, right? And then we will have, oh, their ID is going to be, oh, let's just call it, start at 4 then. 4, we'll make it a long, for int long I equals 4. So we'll put in we'll make an I here. We're going to do an employee I, and then their salary is going to be 50,000 plus I, like that. Okay, and then let's just do 100,000. Oh, it's supposed to be a double. Okay, so we're going to add this new employee. So we've added all of these employees, okay? And so if we then do the size here, employee list.size, we should get 1,000,000. So let's go ahead and run this. Okay, so let's see. Unsupported operation exception. Employee list. Oh, it's because I'm supposed to have a new array list. Yeah, okay, sorry. So I'm going to do a new array list. So arrays as list means it's unreadable. Array list means it takes copies of these elements, puts them in their own list, and now I can add. So let's go ahead and run it. And we should have a 1,000,000 records. Yep, we got 1,000,000 records in here. We have 1,000,000 records in here. So what we want to do is we want to go back and copy that one for loop that does this. So we're going to do an employee list dot stream for each. Is this even possible? I'm kind of curious here. So we're going to do this employee list dot stream for each, and we're going to put this inside of a list. EMP list 1 is equal to that. And we got to do a collectors to list. Oh, it's a for each. Shoot. Let's do a peek. And then we're going to do collectors to list. There we go. Okay, so now we have employee list 1 that has all of the values, right? But what we're going to do is we're going to do something that looks like this. So Java take or timing a method call. Let's see what the code is. How do I time method execution in Java? There's 42 answers. Nice. There's always the old-fashioned way. Yep. Okay. So we're going to do this. So start time is equal to system.nanotime. This is going to be the method that we're going to test. And then we're going to then print out the duration. Okay. And this is in nanotime, so we should be dividing by this to get milliseconds. So divide by this. So duration is equal to this, divide by this to get the milliseconds. So let's put a double here. And let's run this. So single loop duration. I don't know. This might blow up in my face. I don't even know if this is going to work, guys. So let's just try it out. So we're going to run this, and we're going to see what the duration of it is to increment the salary and bring it all back. And a single loop iteration took 90 milliseconds. That's pretty fast. Let's add an extra 0 here, because that should make it slower. Okay. There, look at that. Oh yeah, there we go. There we go. So 10 million took actually it's 1.7 seconds. So 1700 milliseconds it took to process this line of code right here. Okay. So now what we want to do is we want to do this. So parallel the for instead of the for each, we're gonna do the same thing. We're gonna do a peak, and then we're going to do dot collect. This might blow up in my face. And we're gonna do list of employee, emp list 2. So what should happen is it ran this 1 by 1 by 1 by 1 by 1, right? But what we want to do with this one is we want to run this where it's running in parallel across our CPUs. Okay, so let's just do start time is equal to system.nanotime, and then we're going to do end time is equal to system.nanotime. All right, so basically what's happening is we get the start time, we execute the method, and then we get the end time afterwards, and then we just subtract the 2 times and divide by 1 million so that we can get milliseconds. Okay, and so we're going to do the same thing. It might blow up in my face. It might even take longer. I don't know. We're experimenting here. So parallel loop duration. Okay, let's go ahead and run it. And it's taking a long time for it's going to take a long time for the first one. And then we'll see how long it takes for the second one. There we go. Oh, look. The parallel loop actually ran faster than this one. So let's do this. So size. No, we don't need size of loop. Yeah, we do. We need size of loop. So size of loop, or size of list, where it's going to give us the size of the list, but now we're going to make it even bigger. Let's see if we can actually get a really huge difference in the amount of time it takes. So this thing is going to take a long time. I might have made it too long. We're looking at 1, 2, 3, 4, 5, 6, 100 million. We're looking at 100 million, processing 100 million right now. Wow. It is taking a long time. 100 million is not that much. What? What's going on with my computer? Jeez. So the 1.7 seconds, right? So if we multiply that by 10, shouldn't it take 10.7 seconds? Or is it exponential? I'm trying to remember. So it took 1.7 seconds before, but we're multiplying that by 10, so it should be 10 seconds. That should have already passed. I think it's exponential. I think, there we go. Great. Oh my goodness, I ran out of memory. Dang. Okay, well that's not a good test then, because I ran out of memory. So let's go back to 10 million. Let's run that again. Okay, so just to reiterate, a CPU, there you go. So the first one was 1.7 seconds, this one is 0.8 seconds. Nice. So parallel makes it so that you can run multiple things or multiple records in tandem, well, across different CPUs, so you're actually using different hardware, and then it'll execute faster for you. Here's the issue though, they have to be independent. So these calculations are all independent. I multiply each salary by 10. If the salary is dependent on somebody else's salary though, then the logic starts breaking down because now it's no longer independent. You can't actually split up the operations across different CPUs. So this is where parallel breaks down. You have to be aware of this. But it is pretty cool that you can automate. I mean, with just a simple keyword, and this is what made Java streams. With just a simple keyword, you can now do parallel processing. Awesome. And if you know anything about thread development, you're gonna have to have you have your wait. Shoot, what are they called? You have to create multiple threads. Like they're very difficult. You got to create multiple threads. You could end up with threads getting locked with each other because one's waiting for the other one, type of thing, and very complicated. So when Java introduced this, it was awesome. Okay, I think we're good there. So I think that pretty much covers everything. Let's go back to the page here. I think we're good. There's more here if you guys want to read, but I'll leave that to you if you're interested. I think we've covered more than enough. So just remember, let's do a quick summary. Streams, they're going to ask something along the lines. They're going to ask either like a technical question, like I'll give you an example. Like they'll tell me something like, okay, how do you filter out all the names of the employees? You have an employee object. Filter out all the employees by a letter F. Give me all the employees that start with the letter F. Okay, and you're gonna have to write that out. And if you write it out as a function or as a for loop, that's great, right? You solve the answer, you're good to go. And then they always follow it up with, can you write it as a string? Okay, so you want to be prepared for that. Okay, so you want to know how to use the map operator. Map operator is really key, huge. Anything with sorting, you definitely want to know how to use that. For each is also popular, but not really that much. For each is kind of like a convenience method for a for loop. Map is the thing that gives you the power of converting one data type to another. Collect, I haven't really used this as much, but if you got really good with it, it'll just help you out. Filter is huge. Find first, I really haven't found anything. There are use cases, but as far as interviews are concerned, it's just one of those things nice to have, right? Nice to know. To array is key. Flat map could be very. I could see this definitely being used in an interview question. And remember, before I do not have a deep mastery of this, so I never used it. So any solution that I did find, or any interview question that was given to me where I could have used a flat map, I didn't. I found another way of doing it. I don't remember off the top of my head any of those type of scenarios, but a flat map, I can totally see them. They're throwing out a problem specifically tailored for a flat map. Peek is very useful. You saw that it basically allows us to process an element and as an intermediate operation allow us to continue the stream. So it's pretty nice. And it's different from a map. A map gives you a different data type. A peek keeps the data type the same and allows you to continue. Okay, so it's like a for each that allows you to continue the stream. And as far as like the actual, so here's sorting right here. This is good about the comparators. You want to follow the same order if you want to go in the descending order. Okay, if you ever want to reverse it, then you got to make sure that E1 and E2 is reversed. So you do E2 dot compare to E1. Okay, and if you do that, you'll go in descending order. All right, we covered minimax, distinct, all of these. Yep, this is great. Covered all of this stuff. The final thing that you want to talk about with Java streaming is, we covered these. These are partitioning and grouping by, very advanced. I have not seen these in the field, but if you did see them, you at least know how to approach them. Parallel streams. This is a good talking point. Basically, it was introduced in Java 8 to enable multi-threaded programming for developers in a very, very easy manner. And so with the parallel keyword or the parallel operator, I mean, parallel keyword, parallel operator, same thing. With the parallel operator, you can make it so that your stream is processed across different CPUs or multi-threaded. So let's just break that down a little bit more. A CPU, so let's just look up a chip. Latest Intel chip. Okay, so the latest Intel chip is a, shoot, man, what is it? It's an oh yeah, they have an i9 processor. Look, see right here, delivering up to 24 cores. 24 cores, that means 24 CPUs are on this chip. Now you gotta buy, depending on the version of the chip that you buy, you're gonna, so like this one has up to 24 cores, this one has up to 20 cores, up to 14 cores. So basically, there are 24 chips on this chip. Okay, so the way it's architected, there's like a bunch of transistors on this like substrate, right? And so instead of just having one chip, they've made a copy of 24 of them on that one chip. So in essence, you actually do have 24 chips that can process independently of each other, which is awesome, right? So so this is the hardware. If you have an i9 chip and you use parallel, in theory, you will be processing 24 different streams of data for that one stream in parallel, okay? So in essence, you should be able to speed it up 24 times, right? You should, like, if it takes you 10 minutes, take the 10 minutes divided by 24, and you should be able to, I don't know what that is. So 10 divided by 24 in 0.41. So 0.41 times 60 is 25 seconds. So if you had 24 cores and it was true parallel processing and everything was done equally across all of them, which by the way, it's not the case, but if it was, right, then a 10-minute job would take you 25 seconds. Okay? That's why you want to pay more money for your i9 processor. The thing is nobody really uses the parallel processing, right? Like, it's all basically made for lower tech processors, which the only thing that it tries to use is like, I don't even think games use parallel processing. Yeah. So, anyways, but that's like a whole other conversation. So, if you wanted to take advantage of it, you could do that. So that's just the hardware. You can also do multi-threaded processing if you have one core. Okay, so that's multi-thread programming. So like you can open up a different thread, but there at that point it's not it's one CPU processing multiple threads at that point, and you don't get the benefit of having them all run at the same time on a different hardware. So when I say multi-threaded and parallel processing, you just got to understand that there's a hardware element to it and there's a software element to it. But you really want to take advantage of the hardware element. That's where you really get the benefit of it. I mean, that's it. That's pretty much it. So to break it down again, if you use parallel, you're trying to take advantage of the multiple cores on your CPU to process all of your data at the same time so that it can get to you, so it can get processed faster. Okay? And the caveat with that is the only way it'll work properly is if all of your computations are independent. So if you have one element if you have one calculation of an element depending on the calculation of another element, depending on the calculation of another element, you can't do parallel processing with that because you got to run each of those one at a time because everything's all dependent on each other. But if you have everything if you have everything independent where you have, give me 10% of the value, there's no dependency of one element with another one, then all that stuff will be fast. Okay, so, oh yeah, our test failed. It failed because, because we did not actually save employee list. This should be employee list 2. So remember, because we used a collector here to list, we are not, and we're using a peak here, we are not actually modifying the original array here, employee list. We are not modifying this list. okay, with the peak. Whereas before, the for each, we were modifying it. So that's something else you want to remember. So let's go back and I'll show you real quick. So for each iterates through each element, okay? And right here, we're not changing it. But if you go back to the top and look at the salary, where is it? Where are you? Where are you? We're at the top here. There you go. So you see how we do a for each e.e.salary increment? What we're doing is we're taking the salary and multiplying it by 10, and we're updating e in here. Okay, so for each, and so that's why they do employee list.get 0 get salary, and they want to make sure that it's equal to 110 because you actually modified the employees inside of this list. Whereas here, you're getting a, this is weird. Oh, yeah, okay. Dang it. So what's happening here, yeah. Okay, so what's happening here is we're streaming through this, we're peeking through each element, and we're multiplying it by, we're adding a salary of 10. So we do that the first time around, and that's why we thought we're getting 110, but we're actually getting 121, because what's happening is you can run it through the first time and you increment it by 10%, and then we run it again through a second loop, and each employee gets an additional raise of 10%. So we give them a raise the first time through this, right? And then we give them a raise the second time through this. And that's why the value is failing here. I'll take out these asserts. Okay. There's more to discuss on that, but I don't, we're already getting too deep. So let's just go ahead and just end it here. If you have any questions, feel free to reach out. But this is the Java Streams session. We should be we'll be for next office hours, we'll be doing SQL queries. Thank you for watching, guys. See ya.